Hi guys, this is Shweta Shaw from Million Brains again. So, as we know, for the next 15-20 minutes, I'm going to take your doubts if you have any, and then from 5:15 we will be moving to our today's session. Okay, so let me know if you have any doubts. Till the time you're typing the doubts, I'll just go through what we have already done. Meanwhile, whatever doubts I receive in the comment section, I'll be answering those things. Okay. So, yesterday our plan was to cover machine learning, and today our plan will be to finish one part of the machine learning. We will be seeing one project which we will be using for IoT with ML. Okay, so our task for today will be to cover that. For that, we looked at what machine learning is. So, this was the thing. For machine learning, you actually need to give the machine a lot of data. Once you give the machine any kind of data, so the machine will then extract the patterns hidden in it. So let's say if you give multiple images and also the name of what the thing is in the image, then machine will be learning what is there in the image, which is because of which the name is so and so. Okay, so it is basically going to be like finding the relationship between the input and the output. Okay, so after that, what happens? Once the machine finds the relationship, that means it has found the pattern. It has found the rules, the set of rules using which we can relate the input with the output. Okay, that means now here on, whenever the machine will get any input, it will be using the same rules which it has learned, and then it will be applying the rules on the input and giving you the output. So this was the basic what to say rule of machine learning. So whatever you want to solve, you need to have some uh, data related to that. Okay, and as I told you, many people ask me, can I make this for machine learning? Can I make this a project? Can I make this? Can I do this? Only there is only one single answer. Yes, you can, but you will have to have the data with you. Okay. If you have data related to anything, you can do the task. Okay. Now, we looked at two phases of machine learning after that, where first of all, we had our training phase where the machine is taking the data and learning the algorithm or the pattern or the rule or the relationship, whatever you call it. And then in the test phase, now you can send any new input to the machine and it will pass the input through the algorithm and then give you one output. Okay, then we looked at various applications on of ML. I'm not going to enter into this because whenever I enter into this, then I just keep going in the flow, so I'll just skip it for now. Yeah, but I have one task for you guys. Sure, Nandini, I can repeat the neural network part. Till then, I have a task for you guys. Just 1 second. Yeah, I have one task for you guys. Can you give me two applications of machine learning which are not listed here? Any two applications of machine learning which are not listed here. Okay, so I'll directly jump to neural network, Nandini. So the basic concept of neural network was to develop a thing similar to the neural network we human have. Because using our neural network, our brain can do any complex task easily. Okay. So we were just trying to have a way so that we can depict the same neural networks behavior. Okay, now so to depict the whole network's behavior, you first of all have to understand how a single neuron behaves. So this is what a single neuron looks like. And basically, as I told you yesterday, we are not going to get into the biology. Definitely, what is happening in the neuron will be taking some input, it will be sharing some output. But what this output will be, this input, whatever input signal it had, it will be processing it and then it will be giving you some output. As I gave you one example, let's say I'm holding the one bottle with hot water in it, and then let's say somehow the temperature information is sent to the neural network of my brain. So the first neuron got the information of, let's say this is that these many cells on the skin are right now in contact with the water, and then later on some other neuron will got that, okay, this might be the temperature range. Now that neuron will be processing this input, and it will be understanding that this particular temperature is not good for those cells around my skin, right? So because of just like this, some information will keep on, it just keeps on flowing through your network, and then what happens, in all the neurons some kind of processing is happening. And what is happening, your neuron is getting either some raw information or some already processed information. So we in machine learning we try to develop the same concept, and then comes the perceptron. So this perceptron is one single neuron. It can be considered equivalent to a single neuron of your neural network. So it had the power to take various inputs. It had the power to process the input, and then it had the power to send some output. Okay. Now, not mandatory, but 98% of the cases, your neurons are doing some kind of binary classification thing. Yes, no kind of thing. Okay. Your neurons are doing some kind of yes, no kind of things. So what happens, let's say it got few inputs here, x1, x2, x3. Okay. So it is deciding something. In my last class, I took the example of whether I'll be going to my any food fest or not. So it is taking some input related, though these inputs will be those factors which will be affecting my decision. Okay. And these factors which can have any effect on my decision are called features in machine learning language. Okay. Now these features will be sent to the neuron. Now it's not mandatory that all the features will be equally important for me. Okay, it might happen that my body is sensing that right now it is night. Okay, it is night time, and secondly it is taking the information that the thing I'm holding, the temperature of it is maybe beyond 50. Okay, 50 degrees Celsius maybe. Now, to understand whether this temperature is threatening for me or not, it is not mandatory to know whether it is a daytime or night time, right? So the neuron may get whatsoever information, it may get whatsoever input, but it is the task of the neuron to actually understand which input is important in this decision making. Okay. And depending on the input, the importance it thinks the input has in the decision making process, it will set a weightage to the input. That means more important the weight is, more important the input is, more weight will be assigned to the input. Okay. Now at the processing unit, what will happen, all the weight will be multiplied, all the weights will be multiplied with the corresponding input value, and you'll be receiving a weighted sum. Okay. Now there is also a concept of negative weightage, which I skipped yesterday. What happens in negative weightage, let's say that let me open my page. Yeah, let's say that I am having a feature as a number of hours I'm sleeping. Okay. And the neuron is supposed to decide whether I'll pass or not. Pass is the positive class, and not pass or failed is the negative class. Okay. So here what happens, now as the number of hours I'm sleeping increases, of course number of hours I'm sleeping somehow has some important relationship with whether I'll be passing or not, because the more I sleep the less I'm studying. Okay. So the more I'm sleeping the less I'm studying, and the less is the chances of me passing. So here what is happening, this feature, let's call it x5. Okay. This feature has some really strong correlation, or really strong depend, this passing or not passing has really strong dependency on this feature. So it will get a very high weightage, let's say 8. Now the more is the value of this feature, the less is the chances of me getting passed, right? So that is why this will be having a negative sign over here. So that if it is some a very higher value, let's say I'm sleeping for 8 hours, so the resultant minus 8 into 8 will become minus 64. Money a very low value. A low value will induce an output of 0, right? We just studied this last time. A low value of the weighted sum will induce an output of 0. Now if I am sleeping for less time, let's say 2 hours, though I do not recommend doing this while you have your exam, just an example. So 2 hours, so minus 8 into 2, now it is still negative number, but again it is a very lesser negative number, right? So if I compare both the results, this means I have more chances of failing, this means I have more chances of passing, because this is quite higher number compared to this one. Okay, so whatever the weights are, actually we are no role in deciding the value of the weights. Okay, so how will the weights be decided? The weights will be decided by the machine itself. Okay, what happens? There is also a bias term acting over here. This bias is somehow working as the threshold. So let's say somehow you got a weighted sum. The whole concept is very simple. If the more the weighted sum is, WS, the more the weighted sum is, the more chances are of getting a positive result. Okay, positive result. So uh, the thing is that the more your weighted sum, the more chances are you're getting positive result, but we cannot work on this thing, right? I cannot say the better you score, the more chances will be there of you having the rank 1 in ISB. That is true, but I need, if I mention some let's say some limit, right? So it will be better for me to predict whether you will be having good rank or not if I have a limit. So that limit is nothing but the threshold. Okay, so what actually happened, the concept is if the weighted sum is greater than threshold, then the result is yes, any positive thing. So positive results are shown by 1 in machine learning, and if the weighted sum is less or equals to threshold, then it is shown by a 0. The output will be 0. Okay, so what happens over here? Your weighted sum minus threshold is the thing. You need to find out this weighted sum minus threshold thing. What we do, we pass this threshold to this particular side, I mean on the left hand side. So you get the weighted sum minus threshold value on the left hand side. So the relationship becomes this, that if this thing is a positive number, then your final output is 1. If this thing is a negative number or equal to 0, your final output is 0. Okay, and one more important thing is there, which also plays an important role in giving this discrete kind of output, either 1 or 0, and that is called the activation function. Okay, so this activation function takes the values, whatever values they are, and compresses that in the range of 0 to 1 only. Okay, 0 to 1 only. Now, these functions, after compressing the values 0 to 1, it is going to give you some output. Okay. Now, this output, what happens, as I told you, the weight and the bias, which are the priority and the threshold, these values are decided by the machine. So you will say that, okay, what is happening at the very first time when the machine has not decided? You are assigning some random weights over here. Okay. Now, because there are random values, random weighted sum is calculated, random activated function value will be given out, and you will be getting a random output. Let's say your actual output was 0, but your random output appeared as 0.5. Now, let's call it the predicted output y hat. Now comes the time to calculate the loss. Loss is actually a function, a mathematical function, which will somehow compare the y and y hat value. Okay. So from here, your machine will understand that, okay, I'm supposed to output a value 0, but I'm outputting a value 0.5. So it will go back to the activation function. It will see that, okay, here sigmoid is there. So in order to give an output 0, sigmoid needs a value which is less than minus 6. Okay. Then machine will go to this region, and it will adjust the weights and biases in a way that the machine now will give you a value which is much negative and much less than minus 6. Okay, so basically what is happening, after the machine is giving you an output, a loss is being calculated, and depending on the loss, the weights and biases are being updated. Okay, so the first process where you're just giving the input to the machine is calculating everything, and then you're sending an output out of the neuron or the machine whatsoever. It is called the forward propagation. And the second part where you're calculating the loss and then coming from end to the starting point, and whatever parameters, these weights and biases are the parameters, whatever parameters appears in the path, you will keep on updating them. Okay, so this process is called back propagation. And this will keep on happening for multiple times, because at once you're sending one input, then again you'll be sending another input, then again some updates will be taking place like that. And by this neuron will be understanding that, okay, when what for what kind of values, for what kind of input values, what kind of weights, I mean, depending on what kind of input values are having what kind of output, the weights and biases are set, and they are set in a way that your machine is getting the minimum loss possible. Ideally, we want the loss to be equals to 0. Okay, loss is a comparison function between y and y hat. So if I say the comparison result is 0, that means y will be equal to y hat. Ideally, I want my machine to give a y hat which is equal to y, but in real life, it is not possible. You may get a model which has loss of 0.00000001 01, which is very less, but it is really impossible to get a model of loss equals to 0, completely equals to 0. So in reality, we are trying to find a model which can predict y hat values, which is as close to y as possible. Okay, so this is basically what happens in a neuron. It takes the input, it combines them, and then it passes it through the activation function, which can uh, which can actually, I think there is one more thing which you guys need to know. The activation function acts a non-linearity as well. Non-linearity as well. Okay. Now just think of this thing. Let's say your weighted sum was not. Let's say the weighted sum is w1 x1 plus b. Okay. Now, when you pass it to the activation function, you have 1 plus e to the power minus w1 x1 plus b. Now, this is not the activation, this is just a type of activation, okay? So, you have got this thing over here, and from here, whatever the result is, the output is, just think for the next neuron, now this output is being sent, okay, as the input. So, this thing will be somehow uh, participating in the loss in the forward propagation calculation over here. Okay, and then the next time you're combining the features, see here, let's say there were two features, w1 x1 and w2 x2. You combine them like this, but the next input are like this, one by this thing, the other thing may be 1 plus e to the power minus w2 x w3 x1 plus w4 x2 plus b2. Why? Because every neuron of the previous layer will have different sets of parameters. So when you give these kind of input to the neuron, now what will happen? Here the neurons are combined, this particular neuron is combining the results together, and now the output given by this neuron will be a non-linear combination. Okay, a non-linear combination. Now you will say, what is the big deal in non-linear, right? Why are you uh, hyping it up like this? So if the okay, so it is not always mandatory that your y will have a relationship with x like 2x plus 2, or 3 by 2 plus x plus 1 by 2, like this. Sometimes it might happen that your y is having any relationship with x like uh, 1 by 2 e to the power minus x square plus 5 by 2 x cube. This kind of non-linear relationship can also exist, right? Now, because of the activation functions, because the activation functions are, uh, what to say, in a way they are transforming any output of the previous neuron in some non-linear values, which will be combined in the next neuron or next layer of neuron. So that is why they are introducing also some non-linearity in the network. Non-linearity means your model is now capable of extracting any kind of pattern, okay, be it linear or non-linear. That means your model is more capable, and now you can extract more complex, more non-linear kind of patterns. So this is what happens in your neural network. Three important things in neural network: in the forward propagation, the weighted sum and activation function. And of course, the most important one is the back propagation, the whole process of back propagation. Because if back propagation weren't there, then your network would have been just a random uh, calculation model, right? Because it was just calculating with some random values. So using back propagation only, the actual weights, the actual parameters are being set, for which the model is outputting such values which is nearly equal to my real life values. Okay. I hope that is clear to you, Nandini. So can you say that role of activation function is to set proper values to weights and bias? Uh, See, proper values of weights and biases are set by the backpropagation method, right? So this, okay, this better word would be optimal values, not proper values, but optimal values. Optimal values of parameters are such a value for which you get loss nearly close to zero. Okay. Now, what thing is responsible in doing this? The process of backpropagation. Okay, the process of backpropagation. In this process, we are using an algorithm to update the weights, which I introduced last day as gradient descent. Okay. If you remember, I wrote the formula last day, W minus alpha del J del W. The formula, the algorithm's name was gradient descent. This is a kind of optimizer which tells your model how to update the values to get the optimal value. So these are responsible for setting optimal values of the model. What your activation function is doing basically, it is helping your model in giving yes, no kind of values. Okay, 0, 1 kind of values, and also these are adding some non-linearity so that your model be able to extract non-linear relationship, or I can say be able to extract some complex relationship. So the major role of activation function is in the forward propagation, and the major role of an optimizer is in the back propagation. I hope that cleared your doubt, Chandan. So do we have anything? Do we have any other thing, guys? Let me know if you have any further doubts. Okay, so let's do one thing. As people will be joining, they are informed that today's session will start from 5:15. So let's continue from 5:15 till the time. If you have any doubts, leave that in the comment section. I'll read that and I'll answer that. Okay. So we will continue for today from 5:30, 5:15. Okay, guys, so I think we're good to start today's session. Okay, guys, so I think we're good to start today's session. Okay, I'm sorry for that. Yeah. So last day, the things we covered, actually, we could cover only one concept, that was neural network. Now, I was expecting one question, but I did not get it. And the question was that I told you guys that neural network or deep learning is used for unstructured data. That means we will not directly have the features over there, right? But no one asked me this thing that आपने तो बोला था that we'll be getting unstructured data, features will not be discretely mentioned. First of all, we'll have to extract the feature. But here in the neural network, I showed you that x1 is a feature, x2 is a feature, x3 is a feature. But no one actually questioned me this, that how am I plotting these things, why I'm giving neural network direct features if I do not have them, because deep learning mein to we will only be going when we have unstructured data, right? Now here is one thing, neural network is capable, acha, this thing, the thing over here, this would be called a dense neural network. You have various you have a lot of variants of neural network. This would be called a dense neural network. Why is it being called? Picture is hazy. Jayashree, can you please try watching the video in some higher resolution? If it still remains hazy, let me know. I'll do something. But I think things are fine from my side. Let me know. Try watching the video in some higher resolution once. Okay. So I was saying it is called dense neural network. Now, I don't think you guys noticed because this is a very minute thing. Here, if you notice, this neural network is not completely inside the deep learning part. Okay, this neural network is in between the deep learning and machine learning part. No, Anuj, we're just starting. So I was saying this neural network is between the deep learning and the machine learning part. That means in machine learning we are handling structured data. That means features are discretely mentioned. So these discrete features can be sent to the neural network and then we can get the result. In deep learning we will get unstructured data. There we will be first of all extracting the features and then we will be sending it to the neural network and then we'll be getting the result. Okay, now you will ask me that, okay, if features are already structured in machine learning, then why neural network? We have other models now, logistic regression, linear regression. Then what benefit I'll get if I use neural network? One most important thing is neural network is capable of giving you relationships which are non-linear in nature, or I can say complex in nature. Okay, so that's why if you have structured data, still you can use neural network, dense neural network. If you have unstructured data, then you will be using, if you have unstructured data, then you will be using some part plus dense neural network. Now, you know that this dense neural network can take the features and efficiently combine them non-linearly so that you can have a complex relationship out of the features and the, I mean, out of the data set, right? But what this some other part will do, this part will help you in extracting the features. So that means if you have already structured data, just use simply dense neural network. If you have unstructured data, the way we have images or audios or text, you will be having some other part, we will be extracting the feature. This part is generally called feature extractor. Okay, and the second part is the one which is giving you the result, right? So if we are doing a classification task, This would be called a classifier. Now, depending on what type of data you are getting, whether it is an image, an audio, or a text file, this some other part will keep on changing. And this will give you different variety of neural network. For example, if you're working with images, you can use CNN, convolutional neural network, and this is going to be our topic for today. Before we start the project part, if you're using text, you can use RNN, recurrent neural network. Okay, now what is the difference between, I mean, what is the similarity between CNN and RNN? They both will be having some dense neural network part at the end, but what is the difference? They both will be extracting the feature in different way. So this feature extractor part will differ in CNN and RNN or any other variant of neural network. Okay, we have a lot of things in our plate. So we're going to start with the most important and the easiest one actually, which is CNN. Okay, so CNN, as I told you, is that variant of neural network which is going to help you to understand the images. That means, I think you guys remember last day we saw what is computer vision. So I told you it is that field of machine learning where you give the machine the power to see. Now you will say that okay, camera is there. Using the camera, the machine is seeing only. So you're not only giving the power to see, but also to analyze and then combine everything all together. What it is seeing, extracting some information out of that. When you're seeing my screen right now, you're not just randomly looking at it, you're also extracting some features that okay, the background is a blue color, there is an alien brains logo at the left side, India super brain logo at the right side, and different stuffs over there. Okay, similarly, when we say the power to see, that means to see, that means to take the input whatsoever that is, and also the then process the input and extract some information out of the that. Okay, and as I told you, we will be solving those problems in computer vision which we humans would have solved using our eyes brain relationship. Those problems will be solved in computer vision. That means here my data will be either images or videos. Okay, so CNN is that variant of neural network which we will be using in computer vision. Why you cannot use DNN? Uh, because CNN will have some extra part for the feature extraction. Okay, some extra part which is more accurate in feature extraction from some images. So it is a variant of neural network used in computer vision because it has the ability to understand images and videos well, and it is inspired by the visual cortex of animal brain. If you're not aware of what visual cortex is, it is that part of the brain which handles the input of eyes and then process how whatever we are seeing, how that is functioned and used in extracting information, etc. So this is what we will be seeing today, CNN. And the project which we will be doing is based on this CNN only. But before going into that part, understanding how a neural network named CNN works and everything, the first and foremost thing is understanding that if I give an image to the computer, how the computer is going to make some sense out of it, right? How the computer is going to extract the information or to actually understand the image. Okay, as we know that computers can only understand numerical values, no text, no nothing, only numerical values. And trust me, even if you're storing some audio files, they are also converted into some numerical values and then stored in your device. Okay, so images as well are going to be converted into some numerical values, but they are not just going to be some random numbers. They're going to be a set of numbers which will be presented together, and they will be uh, presented in the form of some arrays. Okay, some arrays. Now you will say that okay, arrays are fine, arrays are nothing but what to say, a container kind of thing which will be holding different numbers together. But what numbers will be held there, right? How can we convert image to some number? Like what is happening? Let me tell you what is there in the image. the way you can break any material up to the atoms, right? So similarly here you can break any image up to the pixel values. The smallest unit of the image is the pixel value. Okay, sorry, the number of the smallest unit will be a pixel. Now each pixel, so you can think of this thing, just one moment. Yeah, this is the image, an image which can make me hungry. So let's say this is the smallest unit of the image. Though pixels are much smaller than this one, but let's say this is 1 pixel of this image. Now, what is there in the pixel? Some part of the image. And what is this part? This part is having some color information. Okay. So pixel is actually going to hold some numerical values related to the color information. Okay. Now, what numerical value? It will be holding the intensity of the color. Now, one thing which we might have studied about in class 2 or 3 something, the three primary colors are G, B, red, green and blue. We know that there are these primary colors and every other color in this world is nothing but a combination of these three colors. So these pixels are going to hold the information of the intensity of, how much red is there, how much green is there, or how much blue is there. Okay, let me show you one thing. See, just go to this particular color. This color, I don't know what is the name of this color, but whatever it is, this color. Now see, there are these values: 62 for red, 204 for green, 169 for blue. That means the intensity of the red color was 62, intensity of the green color was 204, and intensity of the blue color was 169. Let's go to some other color, this particular color. See, the intensities are different. This particular color, the intensities are different. This one over here, the intensities are different. That means by adding some proportion of red, green and blue, you can generate different colors. So you will ask me, okay, what if we do not add anything? जहाँ कुछ नहीं वहाँ अंधेरा, and that is why when you do not add anything, you will have the black color. Now you will ask me, what if I add everything I have? So let me tell you, numerically the highest possible value for the color intensity is 255. Okay, so see, if I add all the colors to the extreme extent, I'm getting white color. Okay, now any value for red, green and blue in the range of 0 to 255 will be generating a color, and these pixels are going to hold the value for these R, G and B values. Okay, the numerical values of R, G and B, which are called the color intensity values. Okay, so let me just go back to the slide once. Yeah, see, let's say there is 1 pixel which is holding a purple color. So this pixel will be represented by 3 values. One value will be holding the number 128, second 0, third 128 again. If the color is sky blue of the pixel, then again 3 values, and 3 values for that pixel will be holding these 3 numerical values over there. So any pixel, if it is it is a colored image, any pixel will be holding 3 values. Okay, so yeah, so you will be asking me next that what if a pixel is there where two colors are conjoined, right? Like this, something like this, where pink is also there, white is also there. So no, not possible. Not possible. No pixel can have, pixels are so small that they cannot have any not combination, they cannot have two discrete colors in a single pixel. Pixels are so small that they will be having only one color, and for each color they will be having 3 values. Okay, now you will ask me then, okay, how does the array look? You will be asking, how does the array look? Just one second, guys. Yeah, I'm extremely sorry for that. Yeah, I was talking about the color values, right? So you will be asking me that, okay, how will this array look? So this image will have some height and width, right? Yeah, this image will have some height and width. Okay, so the size of the image is generally represented like this. Let's say this one is of 458 cross 953. That means width wise, along the horizon you have 458 values pixels, and lengthwise you have 953 pixels. So the corresponding array, uh, just one moment. Yeah, 458 into 953, right? 458 458 into 953. So the corresponding array will also have, this array is going to have 458 values along this direction. That means it will have 458 different columns. Okay, and because in height there are 953 values, so it will have 953 values like this. That means this array will have 953 rows and 458 columns. Okay, so this is how the conversion of pixel to array will be happening. So you can see the same thing is written over here. Corresponding array will be of the same size as that of the image. The array or the matrix will have 458 columns and 953 rows. Now what happens over there? One more thing, I told you that okay, there will be, if there is one pixel, this pixel will be having three values. But here what happens, your array is actually a three-dimensional array. Mane, like this you have three sheets, like you can think of it as three different sheets of papers, and there are, in every paper there are 458 cross 953 locations built up. Okay, so here what will happen, this paper, the first page is corresponding to the red value only, the second page is corresponding to the green values only, and the third page is corresponding for the blue values only. Okay, now for this particular pixel over here, the three values, the first three values of all the three pages will be corresponding to this first pixel value. Let's say the three value, the three color intensity were x, y, z. So here x will be written, here y will be written, here z will be written. Okay, let's say the pixel over here and the value was alpha, beta, gamma. So here at this location in the R channel, alpha will be there, in this channel beta will be there, and in this channel gamma will be there. Like this, for each pixel you will have three values which will be present in these three different pages like structure, and in what to say, mathematical language or maybe image processing language, these pages are called channels. Okay, so basically what I'm trying to say, for every pixel, for every image you will have an array of the similar size. The array will be of three channels because the array needs to hold the value of three color, right? Red, green and blue. Okay, and the every pixel will be having three values, and the three values will be stored in three channels at the corresponding location. Okay, that means where the pixel is in the image, at the same location in the array some numerical values will be there. So this is the thing over here. Let me know if we have any doubt till now. Let me know if you have any doubt till now. Okay, if not, then let's move to the other thing. This is what your any of your colored image will look like, right? Three channels, the first channel corresponding to red, green, and second corresponding to green, third corresponding to blue, and what values are stored, we know it, right? But what happens when you get a black and white image or a gray scaled image, because there are no color, right? So you cannot say that okay, theek hai, to in every pixel there will be either 0 or 1. No. If you notice, these images are not completely black and white, na? Because see, there are different shades of gray, right? There are different shades of gray. Again, an image which can make me hungry anytime. So coming back to the paint so that we can write over things. Yeah. So here what is happening? You are getting different shades of grays. Here we have the same thing. Naveen, yeah, X for red, Y for green, yeah, Z for blue. Yeah, that is what I said. Can you please array part? Okay, I'll come to it. I'll come to it, Jayashree. I'll come to it again. Now, this grayscale image is now having one channel only in the matrix. The size of the array will be calculated in a similar way. Let's say if there are 800 pixels this way and 600 pixels this way. So there have to be 800 values stored along this way, right? So that is why it will be having 800 columns, and there have to be 600 values stored along this way. That means here we will be having 600 rows. So this will be your corresponding array. Now, what values will be stored here? Here also values in the range of 0 to 255 will be stored. But here single values are stored. Mane, each pixel is holding a single value. And this value is representing me the shade of gray. Okay. There are 254 shades of gray. See, up from 0 to 255, total 256 values, right? Where 0 means completely black, 255 means completely white, and other 254 values are corresponding to different shades of gray. Of course, 30, which is a very smaller value, 30, which is a very smaller value, is corresponding to a very bright gray. Okay, and let's say if you have a value like 200, that means it is a very dark shade of gray. Like this, the different shades of gray in terms of some numerical values will be stored in a grayscale image. Okay. Uh, so this is basically how our computer is going to understand any image. So Jayashree, I said that any image will be corresponding to an array. Array is nothing but it is going to hold multiple values all together. Okay, there are multiple values being stored over here. Any colored image for any pixel, there will be the pixel values, whatever value is hold in the pixel will be stored in the array. Now every pixel in the colored image is having three values. That is why it's like writing in three pages simultaneously. Okay, so this is why you have three channeled array, or this thing is also called a 3D array. Not because of the three channels, but because you have height, width, and depth as well. Okay, and here at each location, the way over here, uh, yeah, the way over here you're getting for this pixel, you're getting these three values. So for the next pixel, you're getting the other three values. Like this, all the values of the pixels are stored in the array. Okay. So this is how your computer is going to read any image, be it a colored image or a grayscale image. 200 is bright. Did I say dark? 200 is for a bright gray and 30 was for a dark gray. I'm sorry if I said something, if I mixed things up. Anyway, this is what input. Basically, when you're having images, so you're actually going to get arrays as input, right, to your computer. Now, for any this kind of data, when you are getting images or videos, you're going to have CNN. As I told you that CNN has the ability of extracting features out of the images. Now CNN, the full form is convolutional neural network. As I told you previously that you should better focus on the name. Why is it named like this? So after 15-20 minutes, maybe you will be understanding why is it called a convolutional neural network. Okay, so a basic SE, and the name is convolutional neural network. That means here again multiple layers will be present, but the basic type of layer which has to be there in CNN, There are 4 types of layers: convolution layer, activation layer, pooling layer, fully connected layer. Now, don't think there are only one convolution, one activation, one pooling, one fully connected. No, there can be 20 convolution, 10 pooling, 50 fully connected. This completely depends on us. How many layers we want in our network. But for any convolutional neural network which you make, these 4 kinds of layers has to be there. Okay, so we will be understanding CNN by looking at these layers one by one. The first and the most important is convolution layer. Because we have such a layer in CNN, that is why this model is called a convolutional neural network. Now the thing is, then why this layer is called convolution layer? Okay, this kind of question should arise in your mind. Okay, so coming to the convolution layer, very easy. The reason why you have to have these kind of things, convolution layer, pooling layer and everything, is images are having the features, but the features are not opened up and given, what to say, um, presented discreetly. Okay, I have one example over here. Just give me one moment. Let's say Amitabh Bachchan. Okay, this image, and let's have Shah Rukh Khan. Okay, this image over here. Yeah. Now, see, if I give you these 2 images, you will definitely be able to recognize who is Amitabh Bachchan and who is, I mean, which image is of Amitabh Bachchan and which image is of Shah Rukh Khan, right? Because you know how do they look. Can you tell me what are, so if I ask you to recognize any person, you're definitely going to look at the face and then tell me. Can you guess what are the features of these facial images? Features are what? Which are the factors which are going to help you in recognizing someone, right? So what are the features in the face? Can anyone guess? Okay, Imtiaz neural network is consisted of input, hidden and output layer. Output layer is the last layer of your network. In our CNN as well, we'll be having an output layer. The input layer will be the first thing which is being sent to your network. And for the hidden layers, uh, the all these layers like the convolution layer, the pooling layer, all these are some hidden layers only, but they are different types of hidden layers. Okay, nose, eyes, lips. But tell me one thing, nose, here also the some one nose is present, here also one nose is present, here also 2 eyes are present, here also 2 eyes are present, here also lips are present, here also here also lips are present. So how can nose, eyes and lips be features? But I mean, I understand these are present in face, but I want to recognize Amitabh Bachchan and Shah Rukh Khan, respectively. So how can we do that? Because nose to दोनों के image में, skin color, okay, ठीक है. But there will be, let's say, there are 10 actors. Out of those 10 actors, maybe 5 of them are having same skin color. Answer. From its Meg's world and you're living in it. The best part of the answer is distance of facial features from each other. Now, skin tone is not a very good feature. Why? Because I can put on makeup and my skin tone may go up or down. Hair length, I can cut my hair anytime. Okay. Color, again, the same thing. But the last one, distance of facial features, very important. Okay. So here what happens, in any of the pictures, see, let's just have this thing. In Shah Rukh Khan's image over here, some facial features are present, right? What facial features? Eyes, nose, lips, cheekbone, chin, and everything. But these are actually not the features of this particular image. The features are, let's say if I call this point point 1 and this point point 2, So what is the distance between P1 and P2? Okay. If I call this point point 3, so what is the distance between P2 and P3 or P1 and P3? Okay. If I say that these are two lips, these are 2 points near the lips. So let's call it X and Y. So the distance between X and Y will be the feature of Shah Rukh Khan's face. Now you will ask me why? Because Shah Rukh Khan has also a pair of eyes. I also have a pair of eyes. Okay, I also have a nose. I also have lips. So if I say that eyes, nose, lips are features of the face, doesn't make any sense because everyone will be having it. Then how will be recognizing between people? Different peoples. So basically there are multiple points in the human on the human face, and the corresponding distance between all these points are the features, because the structure of Shah Rukh Khan's nose and my nose are definitely different, and these structure of anything is given by the distance between various points on the face. So depending on the models, we have either 68 or 120, 68 or 128 points are there on the faces, on the face. Okay, and distance between all these points will be our feature. So let's say yeah, so my feature is, what is the distance between P1 and P2? Let's say P3 and P4. What is the distance between P3 and P4? Okay. What is the distance between P5 and P6? These kind of things. Okay, over here. So what uh, yeah, so these are the features. Now when this image is sent to any network, your network is supposed to recognize the presence of these features. Okay, why I'm saying this is an unstructured data set? Because no one is telling me that okay, the distance between P1 and P2 in on Shah Rukh Khan's face is 4 units, or the distance between P3 and P4 on Shah Rukh Khan's face is 5 units. No one is going to discreetly tell me this, but the information is present in the image, right? So in our CNN, the convolution layer or pooling layer, these are going to help me in extracting these kind of features out of the image. Then the fully connected layers will be working on the extracted features and giving you the results. Okay, I hope I've cleared my point here. If you have any doubts, then ask. Okay, coming back to the yeah. So I was starting with convolution layer. Now convolution layer is the main thing over here. Is the most responsible thing over here. Okay. So you have convolution layer which can be which can help you in extracting any features. Okay, which can help you in extract any feature. What it will do, just like a what to say, I am just out of the word for this person, detective, right? Sorry, I'm extremely sorry, I just forgot what these people are called. uh, Convolution layer, like any detective, will go over the image and it will try to detect some patterns, the features present in it. Pattern would actually be a wrong thing, but features would be a good thing. Okay, whatever features they are. Now, I just spoke about the facial images of various people. Let's say you need to differentiate between cat's image and dog's image. So just think of what features will be there in cat's image and what features will be there in dog's image, because they are not merely distance between the points. No, यहाँ पे points, there is no story of any points over there. Till then, let me continue over here. There are these layers which are trying to detect the patterns present in the image. So this is the task of the convolution layer. Now we need to understand how convolution layer is doing it. Okay. Now just give me one moment, and till then, please give me the answer of what do you think will be the features which may be the features present in any cats or dogs image. Okay, just 2 minutes. Hmm. Okay. Okay. I did not get any answer for uh features for cats and dogs image. Just try, guys. I'm not going to answer that. You need to try for it. Anyway, so here I'll be seeing how the convolution layer can help you in extracting whatsoever features are present. See, right now, maybe few of you are not able to understand what features are there. This is the case every time. We really do not know what may be a feature in this image, right? So that is why this is, we just leave this task to the neural network that, okay, see, I have the image, I know what this image is, so I have the image, I have the label. I don't know what is the feature, I don't know how is the label related to the feature. You take this data, do whatever you want to do, and just give me the just learn to give me the good results or right results. Okay, now let's see how the convolution layers work. Okay, yeah, right. Tails, tails. Do they have different tails really? Face shape, yeah. Whiskers, good point. Yeah, shape of nose, again, a very good point. Yeah, right. Color of eyes can be considered, but yeah, shape of eyes is very important. Shape of the pupil is very important. Yeah, these kind of things can be there. Now, position, color, and shape of eyes, nose, and mouth, and ears. Yeah, exactly. These are the thing over there. But as I told you, still there would be some people who do not know that how to, extract the feature, understand what features are there. So even in that case, it's not a problem. Do not worry. Neural network is going to take care of everything. Okay, so CNN is going to be something which I'm going to compare with cooking. So what happens in cooking? You have various ingredients, right? But you cannot just mix them randomly. There has to be a proportion. So you will be having some ingredients, and if you mix them in some proportion, good proportion, then some dish would be cooked, right? Similarly, in CNN, what we will be having, the pixel values of the image are going to be my ingredients. I need to mix them, right? I need to combine them, and I need to extract some information, some feature, and the proportion thing, like which pixel will be mixed, how much. This is controlled by the filter values. Okay. Now, what are filters? We will see it shortly. And then after this combination, we will be getting the feature information. So let's not waste time over these things. Let's just directly jump to the working of convolution layer. So here, what is the thing? We have some images of X and some images of 0. So when we will be converting these image, acha, what is our task? To classify between X and 0. That means my model should be able to understand which image is of X and which image is of 0. So my convolution layer, okay, before convolution layer, my images will be represented in some form of arrays, definitely. Here, see, the white pixels are represented by the value 1 and the black pixels are represented by the value 0. Now, this happens because we normalize the image, okay? We normalize the image, normalization. Okay, normalization, or this is also called rescaling, normalization. Okay, what is there? We take any pixel and then we apply this formula over that pixel by max minus min. Okay, where x is the value of any pixel, min is the value of any minimum pixel, max is the value of the maximum possible pixel value, and again min is that the same thing. So in our image wala scenario, the minimum value possible for the pixel is 0. Maximum value possible for any pixel is 255, right? So this formula becomes x minus 0 by 255 minus 0. That means x by 255. That means in order to normalize my pixel values, I need to divide each of them by 255. So let's say if I have a black pixel, so after normalization, this will become 0 by 255. which is 0. We're having a white pixel, let's say 255. So after normalization, this will become 1. Okay. Now a question will be there. I mean, it should be there that why do we need to normalize, right? What is the need of normalization? So I'll come to this in a while, but just get this thing clear from here. 0 after normalization is 0, 255 after normalization is 1. Okay. Now, this is the reason why the white regions over here are represented by a value 1. They were 255 only, but after uh, what to say, normalization, they are converted into ones. Okay. And then you have 0 here. Also see the this region is having all ones, and the other region, this region is having all ones, and the other region are having all 0. Again यहाँ पे these regions are having all ones, others are having 0. Now I want to send these images to my model, and I want my model to recognize what is the, like, to understand what is the feature of these images, and then understand how to recognize them between them. Okay. So what will the machine learn in order to be able to recognize these images? The machine will learn some patterns present in the image. See, some patterns present in the image. So here, if you just notice, just have a look at these three boxes for 2 seconds, 5 seconds. Okay, did you see something? So see, in the blue box, there are some diagonal ones, right? All the ones are going from left to right diagonally. In the green one, again some diagonal ones, but all the ones are coming from right to left right now. And in the green box also, there are some ones present in some specific way. Now, these are some patterns, right, which will be present in X. Okay, if you can see, this is the image of X only, but and there will be multiple other patterns as well, right? Here also, this one, if I take this one, this is also a pattern of what? Pattern of the pixel values which is present in X. But your model will not learn all the patterns. Your model will learn those patterns which is specially present in the image of X. Okay, which is specially present in the image of X and not in the image of 0. So those patterns which are specially present or specifically present in one of the class. So here X and O are two classes, right? So the features which are present in any one of the class are sorry, the patterns present in one of the class and which are not, I mean, which is exclusive to one class, is called feature of that class. Okay. So your model's task would be to recognize the feature, first of all, to understand that okay, this would be a feature in class of X, this would be a feature in the class of O, like this, and then later on checking whether the features of class X is present in an image or not. So they are the convolution layer. They are going to do two tasks. First thing, they are going to extract the features specific to various classes. Secondly, they will be checking whether the features are present in the image, given image or not. If the features are present, features of X are present in the given image, then images of X. If features of O are present in the given image, then the feature is of O. Then the images of O. Okay. So these two things will happen in the convolution layer. Now the machine will be deciding it. The machine will be, okay, the convolution layer. Who will decide what features are specific in an image? I'll come to this. I'll come to this. Now I have another question for you guys. This model, I told you, this will be model will be checking the features of X and the features of 0. Okay. Now let's say if I give an image which is neither X nor O. Let's say if I give it an image of Y, then what do you think will happen? Will your model be showing you some error or giving you what kind of results? What do you think will happen here? So meanwhile, let's move to the next point. I told you convolution layer will be doing two things: detecting what features are there, and secondly, checking for the presence or absence of these features. Right now, I'm keeping the first part on hold, that how the features are detected, extracted, and then we will be moving to the next part where we are assuming that already my model has detected this as a feature. So I will now show you how the model checks for the available presence or absence of this particular feature. Okay. So here what happens, we have this particular feature which I'm assuming my model has learned, and if you can see, this is a feature of X, right? And then here this feature would be uh, convoluting over the image. Okay, and then it will be giving some result. Now, what do I mean by convoluting? Convolution is a mathematical operation which is nothing but the element-wise multiplication of two arrays and then summing up all the values of the arrays. Okay. And secondly, I told you this image, this particular feature, right, is actually called filter. Okay. These are the things which are called filters. So this filter will be moving throughout your image. It will be taking the values from the image and then convoluting. They will be convoluting with them, and it will be giving you some result. Let's just see what how they are going to proceed. Okay, so this is the filter, this is the image, and this star is the sign for convolution. Now see, this is the first time this filter is going on the image. Now see, the yellow part, the would be the highlighted part, money, the filter is working on that part right now. The black values are the values of the image only, and the green values at the corner are the values of the filters. Okay, so what did I say is the convolution operation, element wise multiplication and then adding all of them together. So here 1 into 1 over here, 0 into 0 over here, again 0 into 0 over here, 0 into 0 over here, 1 into 1 over here, 0 into 0 over here, 0 into 0 over here again, 0 into 0 and 1 into 1 at the end. So basically the element wise multiplication money, the element of any particular box of the filter will be multiplied with the same element of the same box of the image. And then after the multiplication, the all the products are added together. So this can be called as sum of products. Okay, they are added together and the value is 3, the value is stored over here. So whether this feature is present at this location of the image or not, this information is given out by this number 3. What is the information? What is there? What is not there? I will come to this slide. Just give me 5 minutes. Okay. Imtiaz is asking, is it always 3 into 3 or that can be adjusted? Completely adjustable. Okay. It's up to you whether you want to keep it 3 into 3, 5 into 5 or what. Veda is asking, it can also match at the right down corner also. Yeah, it will be traveling throughout the image. It will be traveling. Let me show you. So here again for the next location, now this part is highlighted, and again just have a look at the screen. The elements are being multiplied all together. Okay, just have a look at the screen. Okay, so you can see 0 into 1 over here, then 0 into 0 over here, then 0 into 0 over here, 1 into 0 over here, like this. All the values are there, and finally the sum of the values are is being stored here. Then again for the next step, the filter will again move, again the element wise multiplication and sum addition is happening, and the result is being stored here. Like this, the filter will keep on moving, okay, from left to right. Then okay, let me just try to animate this thing for you. It will be better for you. So you can understand how the filter will move on any image. Let's say this bigger thing is your image and this green part is a filter. Okay.
So first of all, filter will start from here, then it will keep on going left, right, 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 one after the other. It will keep on going from here to here. Once it reaches the extreme right, now it is the time to shift downward. Okay, but it starts from here only. So again, left to right. Okay, once again it has reached extreme right, again from here again, from left to right, then again downward, but starting from left to right. Okay, so it is not a pattern like this. It is not happening that here it is going here, then here. No. What is the pattern? The pattern is from here to here, then again directly here, then working from here to here, then directly here, then working from here to here. And every time the the filter is shifting by one column. Every time the filter is shifting by either one column or one row. Okay. We do not, there is no optimum value in Tias. I'll come to this. How do we set the values or what? I'll come to this in the project. There is no optimum value. We do not know any optimum value. Okay, so the filter will travel throughout your image at first width and then height wise, and then checks if the particular feature is present or not. Once this filter will travel throughout this image, see, this will be my result. Now, definitely, what thing is there? See, there are just some numerical values. So how do we understand whether the filters are present or not? The filters, the value, the output value, the greater the output value, the greater the chance is that the filter is present at that region. The less the value, the less the chances that the filter is present in that region. Okay, now why is that so? See here what is happening. If your filter is entirely matching up, or I can say the exact values are coinciding, then only you are getting the highest value. See, 3, when the filter exactly coincided with the image. For any other thing, the less is the coincidence of the values, the lesser will be the value. Okay, so what happens over there? See here also what is happening. Some coincidence is there. That is why it is showing you a 1 there. Okay, now the more the value of the output, the more is the chance of the pattern being present over there. Okay, now again here also you will say that, okay, you're telling me the same thing. You said neurons cannot have higher chance, lower chance kind of thing. They need to be only 0 or 1. So how can you say it over here that here some greater chances and lower chances are there? See here, after this again some bias can be applied here. Okay, so let's say you want your model decides that your bias is uh, mm, let's say your bias is 1 only, -1. So when from every value -1 is -1 is added, so this becomes 2, this becomes -1, this becomes 0. So what will happen? The positive values will be the places where the pattern is exactly present, and 0 and negative value will be the places where the patterns are not present. But we do not know what will be set as the threshold value. I mean, what will be the bias? I do not know that, right? Machine is going to decide that. So basically what is going to happen, if the filter coincides with the exact values in the image, that means the filter is present, right? And that is when you will get a very higher value in the output. Okay, now when you are getting a higher value, then what is happening over there? A higher value shows a greater chance of the filter being present in that region, at that region, and lesser chance of the filter being present in the other region where there are any minimum values. Okay, now this is about the shape. Let's say if there is an image of shape n cross n and there is a filter of shape f cross f. So the resultant of the convolution operation or the convolution layer will be of this shape, n minus f plus 1 cross n minus f plus 1. Okay, and you can see here it was 1, 2, 3, 4, 5, 6, 7. 7 cross 7, and this is 3 cross 3. If you apply the formula 7 minus 3 plus 1, 7 minus 3, 4 plus 1, 5. So the resultant would be 5 plus 5 cross 5, and you can count this is actually 5 cross 5. 1, 2, 3, 4, 5. Okay, so this is what will happen over there in any convolution of any filter. This is how the filter will be reacting with the images, and the numerical values, the greater the value is, it is showing that feature is present. The lesser the value is, that it is showing the feature is not present. Okay, so this is the thing which happens in the convolution layer. But you can see there is one thing. I am discussing everything for a 2D array. 2D money, there are only height and width. See, there are no channels, money, no depth. But in general, what happens? Your images are mostly colored images, right? Whenever you take any images, they're colored images. That means that means 3 channel images. Okay, that means 3 channel images. So what happens over there? What happens when you have multiple channels, right? What about the other channels? So in this, I demonstrated this using a 2D filter, a 2D image and a 2D filter. But actually what happens, or this can be the case of grayscale images, but actually what happens, the number of channel is equal to the number of channel of image is equal to the number of channel of the filter. That means if you're getting an RGB image, there are going to be 3 channels, so the filters are also going to be 3. Okay, I mean the channel in the filters are also going to be 3. Now you will say then, okay, what will happen over here now? Similar thing will be happening. The way filters propagated in the 2D image, similar thing will be happening. See, from left to right, then back to left, then left to right, then back to left, like that. But previously, area was the thing, but here volume is considered, right? Here a volume, a depth wala stuff is moving. That is why volume is considered. Now just check what is happening over there. Just give me one moment. Yeah. So let's say this was a 3 cross 3 filter. Again, there are 3 channels, so it becomes 3 cross 3 cross 3. So in the first channel, there are 3 cross 3, total 9 values. In the second channel, again, there are 3 cross 3 values. Okay. And in the third channel also, there are 3 cross 3 values, like this. So overall 9 values here. Okay, 9 values here, 9 values here, 9 values here. When this filter goes to the image, it goes to all the channels of the image simultaneously. That means here 9 values are going to get multiplied with other 9 values. Okay, the way we had the multiplication previously, again here 9 values multiplied by other 9 values. Here also 9 values multiplied by other 9 values. Okay, now what happens over here? From here, the multiplication of all these 9 elements are going to give you 9 products. From the second channel, you're also going to get 9 products. From the third channel also, you're going to get 9 products. Okay, so the resultant would be not these 9 products individually, but rather all these 27 products are added together to give you one single result, which will be stored here. Let's say the result is 5. Previously, if I just go to that place where we were working with the uh yeah, this kind of image, see what happened. At a time 9 products we were getting over here, which I have written in red. 9 products were added together to give you a single value. But in 3D matrices or in colored image, the filter will also be 3D. The number of channel in image and filter will be same. Each channel of the filter will be working on each channel of the image, and finally the product of all the channels are added together to give you a single value. So here, even after the convolution is happening in between 3D matrices, but the resultant will be 2D. This is the wrong thing over here. The resultant matrix is still 2D, not 1D, because it is storing the sum of channels as well. That means the sum of values, and then the sum of values across the channels are also added.
to give you a single to give you a single product over here. Now here the concept is again the same, right? That the more is the product or the more is the value, the more is the chances of the feature being present over there. Which feature? The feature which is represented by this particular filter. Okay. Now this is about, as I told you, there would be one filter for each feature, but definitely we just saw that there would be always multiple features present in the image, right? That means anytime I will have to pass my image through multiple filters as well. Okay. Okay. So here we will not be exposing the image to a single filter, rather we will be exposing the image to multiple filters, so that at the same time multiple features can be extracted from my image. Okay, every filter will be responsible for some other feature. It might happen, just a second, let's just consider the case of digit recognition, right? Digits 0, 1, 2, 3, 4, 5, these kind of digits, okay, up to 9. So here it might happen this filter is there to recognize this slanted line. This filter is there to recognize this kind of half loop. This is for this, this is for this. There can be different things present, right? Now, every time what will happen, this filter will move throughout the image and the results will be stored in this particular 2D matrix. Okay. Then the result of this will be stored in the second matrix, this in the third, and this in the fourth. Like this, different values will be stored in different channel of the output. See, every channel corresponding to every filter. Okay. Now, okay, yeah, now you will say that, okay, what will be the result then? Let's say this is a 7. Okay, this is a 7. So when this filter moved through the image, this is the result. So the values over here would be, let's say 1. Let's say 1 symbolizes yes, the filter is present. 0 symbolizes no, the filter is not present. So 1, 1, 1, 1. Again, uh, okay, let's say this is the thing over here where you have this horizontal line recognition, and this is for this slanted line. Okay, now when this filter will move through your image, because there are no such curves, so the values throughout the output will be 0, because there are no such curves anywhere. Okay, now for this filter, this will be recognizing a slanted line, so the value throughout the diagonal would be 1 and other values would be 0. Again, this kind of no loops are present in the image, all the values will be 0, like this. So basically this thing is done by the convolution operation, right, which we just read about. So overall, see what is happening. If you have, this is the general case which we will be handling most of the times. For colored image, you have 3-dimensional input. That is why your filters will also be 3-dimensional. Now, the number of channels in your input would be equal to the number of channels in the filter. Mane, if there are 3 channels, your filter need to have 3 channels only. Why? So that these 3 channels can propagate in all the 3 channels respectively and find out whether the feature is present or not. Now, let's say the image was of 3 channel and the filter was of 4 channels. So the first 3 channels will be convoluting over these filters. What will happen to the last filter? There would be no value over which this filter can move. That is why we don't have this kind of scenario. Or let's say there are 4 channels in the image or in the input, and your filter is only 3 channels. So these 3 channels would be a part of convolution, but the fourth channel would not be able to be a part of the convolution, right? That is why you have the same number of layers in number of channels in input, and as the sorry, the same number of channels in the filter as the number of channels in the input, and the number of channels of output would be equal to number of filter. Number in machine learning, number of filter is represented by this thing, okay, this hash mark. So because there were 4 filters, that means we are trying to recognize 4 different features. Okay, and then what is happening? In the output, we're getting 4 channels corresponding to each filter. Each channel is telling me whether this feature was present or not at certain regions. Okay. Let me know if you have any doubt. Okay. I think Shivani's doubt is answered, right? Okay. I think your doubts are answered here. So let's move to the other part. The one thing which literally shook my head when I was learning about convolution layer many years back. So I was so confused that why are they keeping 4 filters only, right? Why are they keeping the size of the filter as 3 cross 3 only, right? Why cannot they keep it 1 cross 1, or why cannot they keep it 5 cross 5, or not 2 cross 2? What is the reason? Okay, so these things over here are called hyperparameters. These things are called hyperparameters. So you will be saying, okay, you have told us about parameters, the weights and bias. What are these hyperparameters? So you have two things, parameters and hyperparameters. Parameters. Parameters, the similarity between them, they both are variables. Okay, they both are variables. The dissimilarities between them, the value of the parameters are set by the machine and the value of the hyperparameters are set by the developers. So hyperparameters are those variables whose values are supposed to be set by us. Now, what are some hyperparameters which we have seen? What do you want to keep the size of the filter? Okay. How many number of filters you want to have in any layer? How many layers do you want to have in your network? How many number of neurons you want to have in your network? All these things are hyperparameter. Now you will ask me, ठीक है, hyperparameter है. Sorry. You will ask me, okay, these are hyperparameter, but what then what will happen to the values of the hyperparameters, right? The hyperparameters values are set by the hit and trial method. There are no known optimal values which we can set to the hyperparameter values. It might happen that your model for some data set was working fine with 3 cross 3 filter. For some other data set, your model is working fine with 5 cross 5 filters. Okay, so you do not know beforehand what would be the value of the hyperparameters. Sometimes 32 filters in a layer will work, sometimes 40 filters would be required, sometimes 50 filters would be required. Okay, but so you do not know what is the optimum value for your model, but what you know, you will have to put use hit and trial for it. So if you put, let's say, 3 cross 3, your model is not performing fine, then you will change it. You can make it 5 cross 5. Let's say it is not performing fine, you can change it again, but there is no other way around. Okay, this is the only method. And what happens with the parameters? The parameters values are chosen by the machine. Okay, so this is the thing, but we actually try to find some shortcuts always, right? So for this part also there is a shortcut. We try to see, let's say we want to do a binary classification, right? Phase mass versus no mass, we are going to do some binary classification. So we will try to find some similar kind of model which already are present over the internet, some binary classification related. And I will take the architecture from there. That, okay, first of all, a convolution layer, there are 32 filters in the layer, the size of the filter is 33, 3,3. Then after that, there is another convolution layer. What so happens over there? We will start with the architecture, okay, and then we will see if the architecture suits my model, my data, well and good. If it doesn't suit, then we will tweak the values up and down. So basically it is going to be a hit and trial method for starters, which we can search for some models which are already working on some similar tasks which we are doing, and then we can start our training process from there. So it would be better than starting from a completely random value. Okay. But again, you do not know whether a value of 3 cross 3 would be fine or 5 cross 5 would be fine. But let me tell you, we actually go on and search the research. We search for some research which has already been done. So depending on my experience, 3 cross 3 filters mostly work. Okay. You do not need to go for 5 cross 5. Now there are some effects of using 3 cross 3, 5 cross 5, 7 cross 7, which we will be talking about in our model architecture when we go to our practical our project work. Okay. So we will be speaking about these hyperparameters in depth, but basically all these things are hyperparameter and you will have to use uh, hit and trial over here again. Okay, Ritvika, hyperparameters are those variables whose values are supposed to be put by us, the developers. So here, let's say I told you that whatever is the size of the filter, here by this thing, this will happen. So here, what would you choose as the size of the filter? Do you want to keep it 3 cross 3? Do you want to keep it 5 cross 5? Do you want to keep it 4 cross 4? Okay, again, whether I also told you that it will depend. Here you can use multiple filters to extract multiple patterns, right? For multiple filters for multiple features, right? So you would think, okay, then if I use thousands of filters all together over here, it would be good for me. So how can you decide whether you should be using 32, 64 filters, 70 filters, 80 filters, 100 filters, 120 filters? How can you decide? So there is only one way. You will have to apply hit and trial. These kind of values which are supposed to be sent by the developer, and they can take any value, but they are supposed to be sent by the developer. These are called hyperparameters. And for hyperparameters, we do not have any rule that okay, यहाँ पे यही होना चाहिए. Okay, you cannot do this, you cannot do that. There are no such rule. You will have to do hit and trial over here only. But there is a narrow scope if there are some research work already happened on the task you're trying to do, then you can start with that architecture. And if your model is not performing good, you can change stuff, but that you can use for starters. Okay. Is it fine, guys? I hope hyperparameters are clear. If not, don't worry, we will be going to see different hyperparameters in our model when we enter our project work. Okay. So basically, here what hyperparameters are there, whether you want to use two convolution layers or one convolution layer or five convolution layers, basically number of layers, or you want to use 10 filters, 20 filters, 50 filters. So number of filters, you want to keep the size of the filter 3 cross 3, 5 cross 5, 7 cross 7. So size of the filters, these are some hyperparameters still here. Okay, now some other hyperparameters are also there. Okay, for example, here if you remember, your filter was shifting by one unit, right? One column to the right, or then when it needs to move down, it will move one row uh, towards the downside. So this thing is called stride. If you put stride equals to 1, that means it will change its location by one row or column. If you put stride equals to 2, that means it will change its location from two rows or by two rows or two columns. So this is also again a hyperparameter. So we have a lot of hyperparameters which we need to have some values for model building or model training. So do not worry, when we will move to our project in a while, we will be exploring these things over there. Okay. So this is the final total number of filters used. If it is n cross c, the input size, so the filter would be f cross f. Why the c is over here again? Because the channels, the number of channels over here in your image would be equal to the number of channels in your filters. And the size that I mean, the shape of the output becomes n minus f plus 1 cross n minus f plus 1 cross m, where m was the total number of filters used. Okay. Now let me tell you one more thing over here. Any input matrix to any convolution layer or any layer in convolution neural network is called input feature map, and any output is called output feature map. Okay, just keep this thing in mind.
So this is what happens in the convolution layer. Your model will have some filters. Model will be convoluting the filters over the image, and then what will be happening over here, the result, depending on the result, your model will be seeing okay whether your features are present or not. Okay, now can you tell me, do you find any similarity between weights and the filter values? Just look at this thing and tell me. I'm giving you 2 minutes or 1 minute. Please quickly try to figure this out. Is there any similarity between the filter value and the weights which we have studied already in the neural network? Can I have some answers? Even if you don't feel there are some similarity, you can tell me no. Do we get some answer? Is there any similarities between the weights which we have learned about and then these filters? They're both multiplied with the parameters, that is the filter. Which are being multiplied with the parameters? Which are being multiplied? Identity matrix, identity. No, Adril, not necessary that the filter will be identity matrix. In my example, it is this way, but not mandatory that they will be always the identity matrix. Any other answer? I'll wait for next 10 seconds. Megha, your answer is quite close, but I'm really confused. What do you mean by they are both multiplied with a parameter? The weights or input feature map. Okay, the weight or input feature map are not the same thing, first of all. Akash is saying in both the cases, more the value, more the product. This is happening with the resultant. I'm asking, is there any similarity between the filter and the weight which was used previously? Weight is multiplied by features. Weight, no. Okay. The thing which is present on the left side of the screen is the image. That means this is input. This is not weight or anything. Okay. This is the pixel values, normalized pixel values. Then the filters are being multiplied. Now see, at any location when the filter is being multiplied, filter is going to each of the pixel values and getting multiplied by it. So filter into input is happening. With the weights also, weight into input was happening. So here filters are similar to weights and the image is the input. So earlier W1 X1 W2 X2 was happening. Here you can consider the filter values as let's say, let us consider the filter values as f1, f2, f3 like this, and the pixel values as p1, p2, p3 like this. So in the convolution, what is happening? P1 into f1 plus p2 into f2 plus p3 into f3, this kind of thing is happening. Previously in the dense neural network also we saw similar kind of thing, which was the weighted sum, w1 x1 w2 x2, this kind of thing. So earlier also some weights were being added to the image inputs. Here also some numbers are being added. So I can say the filters are quite similar to the weights. And one most important similarity, they both are parameters. Okay. Okay, what did you not understand, Adriel? Did you not understand the identity matrix part, Adriel? I said that it is not mandatory that your features will always be identity matrix. Your feature can be something like this as well. 1 0 1 0 1 0 0 0 1.
Your feature can be something like this as well. Your feature can be something like this as well. 013 015. It can be anything. Okay. Weight multiplied by feature. So does the machine alter filter in the exactly, Shivani? That is the point I wanted to make you guys note. Shivani is saying, so she's asking, should does the machine alter filter in the same manner as weights? Exactly. As I told you, filters are nothing but, like we just saw, filters are nothing but something similar to the weight metric, weight values. So here, filters are again a kind of parameters. So, our question, which I think Imtiaz asked at the beginning, that how do we decide the values of the filters? So, we do not decide the values of the filters. The machine itself decides the values of the filters. Okay. Now, you will ask me, okay, how? You're just speaking up. You're not telling us the reason. So, this happens because of using the same logic as used in the case of weights. So you have an image, you have, let's say, only one filter of size 3 cross 3. It acted on it, it gave you some output feature map. Okay, some output feature map. Now, ऐसे ही करते करते there was a lot of layers and finally you got a result. Now this y hat got compared with the y value, okay, and comparing y and y hat you got a loss value. Now using this loss value, all the values in the layer, all the parameters were updated. Similarly, the filters at this layer were updated as well. When the filters were updated, how will the filters be updated? The filters be updated in such a way that the loss over here would be minimum. So it will try to have the optimal values which the filter should have. So basically what happens over here, the way the weight matrix, the weight values were working, filters are going to work in the same way. They are nothing but the parameters. So basically initially initially we will be randomly initializing the filters. We can put 2 0 1 4 3 5 1 2 8, and slowly and steadily your model will keep on updating the values. Let's say it will update this as 1 0, and let's say this was updated 1.5, this was updated as 0, let's say this was updated as 2, this was updated as 5, this was updated as 2. So after few of the updates, it will happen that your filter, originally your filter was supposed to be like this, let's say, but if the as your machine is not going to give you 100% accurate result, so it might happen that your updation will stop at something like this: 0.99, 0.001, 0.001, 0.0002, 1.001. Mane, the values will be somewhat similar to it, but not exactly. Okay, so this is what will happen in the convolution layer as well. The values of the filters will be decided by the machine itself during the backpropagation. We will only be randomly initializing them at the beginning. That's all. Uh, Explain the final output after multiplying the filters. Okay, first of all, filters are not getting multiplied by the weights, Adriel. See what is happening. I told you that this is an image, and this is a part of the image 3 cross 3. Okay, a portion of the image, and let's say the values over there are P1, P2, P3, P4, like this. Okay, let's say I wanted this filter to operate upon the image, and the value of the filter was F1, F2, F3, F4 up to F9. So when this filter went to this particular location of the image, what multiplication I saw? I saw P1, F1 into P1 plus F2 into P2 plus F3 into P3, like this, up to F9 into P9. Similarly, what we saw at the neural network part, dense neural network part, there were multiple inputs x3. Every input had one feature of it, one weight of it, and in the neuron they were getting multiplied together. W1 x1 plus W2 x2 plus W3 x3. So I told you that I asked you, do you find any similarities over here? So one person pointed this out, that the way inputs are getting multiplied with the weights over here, similarly here inputs are getting multiplied with the feature values or filter values over here. So filter values are similar to the weight values. Okay, and filter values, as the weight values were the parameters and they were set by the machine, filter values are also the parameter and they are also set by the machine. So this is what I mentioned about the parameters of the convolution layer. How we get the feature map? Does it comes directly without solving? Okay, Adriel, yeah, this thing over here. This thing over here is the input feature map. Okay, this thing is the input feature map. So we send this to our network. Let's say this is the very first convolution layer, so this is my image. That image is only the input feature map. Then we have some filters in the convolution layer. Okay, these filters are nothing but the parameters. So for the very first time they are randomly initialized by us. Okay, we said that okay, the filter values will be 3 cross 3 cross 3 mane 27 values. We are putting random 27 values, and when these 27 values will work upon the input feature map, and they will give you the output feature map. Okay, be clear with what the meaning of feature map is. You get the output feature map. Now I think your concern is how the values of the filters are getting updated, or how they are getting the actual value they should have got. So yesterday I told you that the weight values are updated depending on the loss. Mane, your Y value actually told your machine what kind of output it is expecting, and then your machine changed the parameter values, the weights and bias values in such an order so that the machine gives the similar result as Y. Here also the same thing will be happening, but on a bigger scale, because here you will have more number of parameters. Okay, the number of values will be extra, but the thing will be similar. Loss will be calculated, and during backpropagation it will be checked that because of this filter, like this filter, how this filter is affecting the loss, and using that thing the filter values are updated over here. And here also a similar formula is used. Okay, let's say in one of your filter the values are, let's say it was a 2 cross 2 filter, and the values were f1, f2, f3, f4. So let's say j is your loss. So your machine will be calculating del j del f1. What is this value? This value tells your machine how much j is affected by f1. Okay, similarly del j del f2, similarly del j del f3, del j del f4. How will it be updated? This particular value, all the values will be updated using the same formula. For f1 updation, f1 minus alpha del j del f1. Okay, then f2 minus alpha del j del f2. Okay, then here f3 minus alpha del j del f3, and similarly here the updation for f4. So after updation, the optimal values of the filters would be received. Okay, now this is only possible because we have a loss function which is telling us that what kind of value of f1 should be in order to get the y which it has calculated the loss with. Okay, so this is what happens over there. Okay, Adriel. Okay, so this is what happens with the filters. And for a long time when I was learning convolution layer, trust me, I was a noob at that time, and I was literally scratching my head that what is happening over here, how are they getting what is the filter values. So filter values are initially randomly initialized. Okay, then during the training phase they are updated, And these two processes of convolution layer, the checking of the filter and also the extraction of the filters, are happening simultaneously. So convolution layer gives you this thing. Now after convolution layer, so what happens with the filters? We do not need to give the values of the filters. The values of the filters are nothing but parameters. Okay, so the values are decided by the machine itself. So just after the convolution, we have the activation layer. Now again the same thing. If you guys have now understood the relation between previous neurons work and right now filters work, you have previously you had w1 x1 plus w2 x2, right? And then again extra stuffs over there, and then you were um, passing it through the sigmoid function. And what sigmoid was doing, if the neuron should have answered 1, sigmoid what sigmoid was doing, it was converting the values into either 1 or 0. Acha, let me tell you one more thing. Sigmoid is just not changing the range, it is also giving you a probabilistic value. Okay, I don't know whether I mentioned it earlier or not. Probabilistic value. And what probability it is giving you? It is giving you the probability of any example becoming belonging to class 1. So if it says, let's say you give the image of you give some image, and the sigmoid of something returns zero point 0.3, that means 30% chances are there that this image belongs to, sorry, 30% chances are there that this image belongs to the class 1, and we have the other class 0 with us. So definitely if this has the probability of 30% of becoming of belonging to 1, definitely 0 will be having the probability of 70%, right? If it says 1 mane 100%, so this is 100% sure that the output is 1. If it is saying 0 mane it is 0% sure that the output is 1, that means it is 100% sure that the output is 0. If it is giving you the sigmoid, it is giving you the value zero point 0.8. That means it is saying 80% sure that the output is the positive class or the class 1. So basically, previously also the sigmoid was working with the input values, okay, and it was pushing the inputs to this particular thing, right? Either 1 or 0. Similarly here also, once you have got the values in the convolution layer, similar thing is happening again, some 310 kind of values. So this convolution this activation layer will be working on the convolution layer, and it will be deciding whether the neurons, whether the each location should be firing or not. So it's like, if the feature is present over there, then it will be putting a 1. If the feature is not present over there, it would be putting a 0. Okay, so this is the working of sigmoid. Not necessary every time the similar thing will be happening. Okay, so just check it out. Yeah, this thing, just read the second line. Give 10 seconds and read what is written in the slide. Okay, so here the second line, specially activation function, again judges whether the neuron will be fired or not. But here we do not have neurons, right? We have each location. So let's say yeah, for this location at this place, at the first location over here, if the sigmoid function in this channel over here is setting a 1, that means this feature at this location was present. Okay, so activations working is similar to what we have already seen previously, so I'm not getting much deeper into it. Again, it adds a non-linearity, so that whenever it goes to any the this particular feature map, output feature map will be the input to the next layer, right? So in that layer a non-linear pattern can be extracted. Okay, so I'm not getting much into details of activation layer, but if you have any doubts you can ask me. If I apply sigmoid to the values 301, this is what the corresponding value would be. Okay, so definitely this is my just random example, that is why I'm getting values like this. But if it would have been a real model, the values would have been more separated, like something in 0.95 range, something in 0.01 kind of thing. Okay, so here I have simply applied sigmoid. Don't get confused that how she is getting these values. The sigmoid value was the sorry, not value. Sigmoid's formula was 1 by 1 plus e to the power minus x. So for any 3, the sigmoid should return you 1 by 1 plus e to the power minus 3. And this is coming equivalent to minus, sorry, 0.95. Okay. Similarly for 0, it will become 1 by 1 plus e to the power minus 0, and it is going to give you 0.5. So whatever values we got, I have written the values over here. So basically it's the same thing. See, the range of the values are now shifted, but again the pattern is still there. Here, the filter which we applied over the image, if you remember, the filter which we applied was 111. That means it is trying to detect a diagonal line, presence of a diagonal line, that too from left to right. Because throughout your image, yeah, throughout your image, diagonal line was present like this. That is why the values at the diagonal are the highest. Even after the activation, see, the values in the diagonal are the highest. Okay, so activation will be telling you whether your like how your model is performing, how sorry, activation will be telling you whether at any location, let's consider this as 1. So at this location the feature was there, that means it is a 0.95 or a 1. Okay, now you would say that, okay, I'm getting 0.95 for presence, zero point 0.5 for absence. What is this 0.73 for? This 0.73 is showing us that there might be some partial feature related, like something related to that feature is present here, but not completely. So if you notice, you have the diagonal elements 111, right? Here also you have the diagonal elements at 0.73. So this 0.73 means that there are something similar to the feature but not exactly the same. Anyway, uh, moving ahead, it will be even this will be removed in the later on layers. But let me move to the next layer of this thing. We have seen two things till now: convolution layer, activation layer. Convolution layer just applies some filters on the image to see what kind of features are present or what kind of features are not present. Okay, both the information are important for me. And also it is also trying to find the value of the optimal features. Okay, then activation layer was just compressing the value in the range of in the known range. It was also adding the non-linearity, and also it was giving you a clear value whether the neuron should be whether the locations of the output feature map should be firing or not. That means whether the features are present there or not. Okay. Now, next is pooling layer, and pooling layer. To understand what is the working of pooling layer, it is very easy. If maximum output of activation layer match, then we can conclude that yeah, exactly, maximum output of activation layer match, then yeah, exactly, this is the thing, Shivani. Then pooling layer is the next kind of layer which we have in our CNN, convolutional neural network. Acha, by the way, because we had convolution layer in convolutional neural network, it is named in that way. Because we are having convolution operation in convolution layer, that is why it is named that way. Okay, I hope the name wala stuff is clear now. By the way, I'll be giving you a break at around 7:30 for 15 minutes, and after the break we will start our project. Okay, so let's continue from this part. The pooling layer, over here, what they are going to be used for, they will always be used after convolution plus activation layer. Mane, you cannot directly send any image. Let's say you decided that I have this image. I have this image. And you said that, okay, just go through this pooling layer. See, it is not going to give you any error. It will pass through the pooling layer, but it will be giving you a no sense value, rather a nonsense value. Okay. So you should never be using pooling layer without using a convolution activation layer. So basically, every pooling layer, it might happen that you send your image through a convolution layer. Acha, by the way, because activation, the way in the neuron, if you remember, we had the weighted sum and the activation both together. Because it is deemed that after every weighted sum activation will be applied, sometimes activation layer is not mentioned as a single layer. Sometimes it is included in the convolution layer only. So even people are not mentioning activation layer, understand activation is there and it is there in the convolution only. Okay. So after that, you can use a pooling layer. This is something you can do, but you cannot directly send the image to the pooling layer. Okay. So the thing is that every pooling layer will have to follow a convolution layer, but it is not mandatory that every convolution layer will be followed by a pooling layer. Okay. I will repeat again. I said every pooling layer will be following a convolution layer, but not mandatory that every convolution layer will be followed by the pooling layer. What did I mean? I meant if you have your image, you might send this to a convolution layer. You will decide that I'll send it to another convolution layer, and then I will use a pooling layer. This is also this is also acceptable. Okay, but image to a pooling layer directly not admissible. Okay, now coming back to this, what is the pooling layer used for, right? So pooling layer basically reduces the number of feature map values. What are the feature map values? Let me show you. So here you have the output feature map as this thing, which is a 5 cross 5 matrix. Money, there are total 25 values, and to the next layer these 25 values will be given. Now, if in the next layer these 25 values are given, definitely these the calculations will be happening with these 25 values, right? So, what will be happening here, if somehow I can reduce the number of values in this particular feature map, then what will happen when the reduced values will be sent to the next layer, so less calculation will be taking place. If instead of 25 somehow, let's say I could send 16 values or I could send 9 values, then the calculation will be happening over these 9 values only. So if there is a way so that I can hold the same information, but I can reduce the size. So what benefit I'll be getting in the next layer, in the next calculation, the next layer's calculation would be reduced. So if calculation is reduced, then it is definitely good for me, because the less is the calculation, the more uh, faster my model's training would be. Okay. So pooling layer is actually used for this purpose only. Pooling layer holds the same information. Pooling layer holds the same information, uh, but it reduces the number of values representing the information. Okay, it reduces the number of values representing the information. So basically, if my number of values are reduced, then the computation in the next layer will be reduced. And if the computation in the next layer is reduced, then definitely it is good for your model. So the basic funda, pooling holds the information but reduces the size of the input. Okay, input to the next layer. So you will ask me how, like how pooling does it, right? So let's just check out two mostly used types of pooling layers, two mostly used types of pooling layer, and we will see how this thing is done.
So the first one, which is mostly used, is max pooling. The other one is average pooling. There are other kind of poolings as well: mean pooling, global average pooling, global max pooling. But these two are the mostly used pooling layers. Okay. Here, here, uh, let's first look at what happens in the max pooling. Let's say this is one of your feature map where I want to apply pooling. Okay. And I said, acha, the way you had filters in the convolution layer, here you have the same thing, but they are called pools or window. Pools or window. So I decide to have a pool of 2x2 filter, 2x2 size. That means at a time 2 rows, 2 columns I am going to take. Okay. And I also decided that my stride would be 2. Stride 2 meaning, stride 2 means that when this pool will be moving, instead of taking one jump and moving from this column to this column, it will move from this column to directly this column, because it will take 2 jumps. Okay. So here in this example, my pool size is 2x2, shape is 2x2, and my stride is 2. Now, what will happen here? So first of all, my pool is going there. Now see, previously when I showed you the filter applied over the convolution layer, the filters had some values, and when the filter went on top of the image, the value went over there and the pixel were multiplied with that values. But here, for the pool, only the part is highlighted. This is because the pool of the pooling layer is a vacant space. It is just like a window, but it has no values in it. Okay, it is just like a window, but it has no values in it. So it is a vacant pool. So first of all, this pool is making this region uh, uh, activated. Okay, activated means activation function wala activated nahi. Activated means right now this is working. So max pooling means the maximum of the highlighted or the activated values will be taken from here to here. Okay. Then because the stride is 2, it is going to move to the next location, which is this one, 2368. Okay. And then again the highest value is 8, it is sent over there. Then here the value 3112, the highest is 3, so it is sent over there. And for the next, the highest is 4, so it is sent over there. Okay. Now, it will now the thing is which I want you to notice here, it is definitely doing one thing, that it is reducing the size, right? Earlier, before the pooling, the size of the feature map was 4x4, but after the pooling, the size of the feature map became 2x2. But also notice how it is holding the information. Max pooling at any location takes only the most prominent features information. So just look at the yellow region in the left side feature map. So in the yellow region, the feature presence was recorded by 4 numbers, 1064. That means the maximum presence of the feature in this locality was 6. So this information was taken from there. So basically what is happening, see, again the same thing. It is not holding the exact value, but see, here, if in all the 4 regions, the highest presence of the feature was in the blue region. Just validate if I'm right or wrong. I said in the input feature map, which is present in the left side, the highest presence of the features are over the blue region. Why? Because an 8 is there. Okay. So in the output feature map as well, see on the right, top right, the presence of the feature is highest. In the input feature map, just see on the top left, that is in the yellow region, the input's presence is second, I think second highest, I can say. That the most the most extent yeah, the presence of the feature in the yellow region is somewhat less than that of the blue region. That is reflected in the feature map as well. See, in the feature map which I'm getting after the pooling operation, the value present in the yellow region is 6, which is less than 8. So although the values are not being held with the utmost accuracy, or I can say the exact values are not being held over there, but the values are somehow representing the same pattern, that okay, at which location the presence of the feature was highest, at which location the presence of the feature was the lowest. Now when I say location, mind it, I'm not talking about a single pixel, I'm talking about the region in the input image. So here the blue region is saying that in the input image, whatsoever the input was and whatsoever this feature is, the feature is most present on the top right space. Okay, and this is what is important for me. Okay, now if I apply the max pooling concept over my input feature map, if you notice, this feature map is the output of the activation function which I got previously, right? See, 0.95, 0.5, 0.73, this kind of value. And here if I apply 2 cross 2 pool, and with stride equals to 2, then I'm getting this corresponding output feature map. Okay, this corresponding output feature map. Now what is happening, just see, definitely the size is reduced. It was 5 cross 5 and now it is 2 cross 2. But see, the pattern is still there, that from the image left to right, the filter is present the highest. There are some filters present which are similar to this filter, but they are present in diagonal from right to left. So this same information which was there in this images, this feature map as well, is present in this feature map, but the size is reduced. So this is what the pooling layer is used for. Okay, let me know, do you guys have any issues here? I'm giving you 10 seconds. Let me know, do you guys have any issues here? Okay, okay. I guess no doubts. So let's move ahead and go to the other type of the pooling layer, average pooling. Okay, so it does the same thing, holds the information, but reduces the number of values. But instead of maximizing the values of any pool, it finds the average of the value. So what was happening in pooling, in max pool of any activated area, I was taking the most prominent feature information. But in the average pool, I'm combining all the feature information's value. Okay, so see, when it is going on the yellow region, this is what we are getting: 1 plus 0 plus 4 plus 6 divided by 4. The average of the four values, 2.75. Then for the blue region, we are getting 4.75. Then for the red region, 1.75. And for the green region, we are getting 1.75 as well. Now see here, you will say, how is it different from the max pooling layer? So it considers all the all the information of features presence or absence in any locality. Whereas max pooling was only considering the maximum information of the maximum feature presence. But here, the presence of, be it a maximum presence, a minimum presence, or a mediocre presence, all the feature presence informations are combined together to give you this kind of result. But here again, see, the similar kind of information is there, that the feature is mostly present in the blue region, then secondly present in the yellow region, and then the red and the green region. Okay. So, okay. When traversing 5 cross 5, a 2 cross 2, will it cover the whole thing? No, it cannot cover the whole thing. No? It cannot cover the whole thing. The sides will be removed. That is why, let me show you. Just one second. Yeah, over here. So first of all, your 2 cross 2 is going to go here. Okay, next it is going to go here. It cannot go here because it will be getting a blank portion. So this part will be ignored. Then it will come here. Then it will come here. Again, no other traversal can happen. Now again, it can come here, but again here also some vacant spaces will be there. So that is why when we are traversing 5 cross 5 with a 2 cross 2 pool size, some boundary values will be ignored. Now here you can say that okay, out of 25 values, your model ignored 1 2 3 4 5 6 7 8 9 10 values. Okay, 1 2 3 4 5, sorry, 9 values. So this might seem a problem here, but in general we work with very large images like in the range of 220 cross 220. So over there, if my model somehow ignores let's say 100 values out of the 40,000 values or things like that, then it is no big deal. Okay, why can we considered what is acha, if there are features like 0.001, 0.3, 0.034, 0.99, then 0.99 will be taken. Will it not suppress the other features? Like it may be, it results in decrease in accuracy. Sometimes it may do so. Sometimes it may do so. But again, what pooling layer you should use, whether you should even use pooling layers or not, it depends upon your use case. Okay, so generally we use pooling layer to reduce the feature values of the feature but take the information forward. But yeah, sometimes it may create some problem, so again you'll have to hit and trial for it. Why or how is 2 cross 2 pool is chosen and not 3 cross 3 or 1 cross 1? Again, the same reason, Ritvika. This is a hyperparameter. You can even choose 3 cross 3 or 1 cross 3 cross 3. 1 cross 1 you should not choose, because even if you apply 1 cross max pooling over 1 cross 1, it is going to have the same thing, right? If you just choose a 1 cross 1, that means it will take one value only. So max pooling or average pooling or anything, it is going to not convert the value, and the overall size will remain as it is. So 1 cross 1 should not be chosen. But yeah, you can use 2 cross 2, 3 cross 2, anything. But you will have to hit and trial to see which model is performing the best for you. Yeah, but in general, mostly 2 cross 2 is chosen in the max pooling line, because in most of the models, this value performs the best. Another reason is 2 cross 2 completely converts the size of the input into half of it. Okay, why can't the boundary values be considered as zeros? No, it will not be considered as zero like this, but there is a concept of padding, uh, Rutviza. There is a concept of padding. What happens if you pad your values? So there would be some uh, yeah, there would be some extra zero values added to your boundary. Okay, you can pad it like this, that you want to add a layer or a row of zeros and a column of zeros, and then you can apply 5 cross 5, then these value will also be considered. Okay, but you will have to do this padding if you want to do padding or not. If you want to do padding, then how many layers at the top, at the bottom, at the left, at the right you want to have, you will have to decide. Your model will not, is not going to do that. It will just clip the values if the values are not fitting in the uh, uh, filter or pool. Okay. Okay, do we have any other doubts here? Do we have any other doubts here? See, Ritviza, it is not mandatory that always using pooling will definitely increase your accuracy or things like that. Okay, so not mandatory that pooling will increase your accuracy. Similarly, not mandatory padding will increase your accuracy. But definitely your model will be taking a lot of input. It will not be leaving any input. So chances are that it might give you accurate results.
but this is not always true. Okay, so I cannot give any certain answer that yes or no. You will have to check. Normally, in an image, boundaries do not hold much information. That's also a point. Normally, in an image, boundaries are mostly exterior points. Mostly, the objects are in middle of the images. So, even if I ignore some of the boundary values during my pooling operation or anything, it won't create much of a problem for me. Okay, ठीक है. Okay. Okay, then let's move ahead and quickly finish the CNN. There are not much part left. Must sorry, much parts left. I'm so sorry. Okay. So we have done with pooling, right? So basically, I told you there are two types of pooling: average or max pooling. So now you'll be asking me, okay, then what pooling we should use in our model, right? Average or max? Again, hyperparameter. It is hyperparameter. You will have to check, you will have to apply both the things and check which is performing best. But there is again a way out. Okay, we have a way out for every hyperparameter thing. What is the way out over here? If you're working with models which doesn't care about the location of the feature, but it only cares about whether the features are present or not, then you will be using max pooling. I repeat again, if you're working with a model which does not care about the location of the features, but it only cares about the presence or absence of the features, then you can use max pooling. Example, image classification. Let's say if there is an oval pupil present. Okay, let's say apple and mango, let's just consider that. If the shape is oval with a dent, right, so it will be a mango. So it does not bother whether your dent is okay, no, that would not be a good feature, because feature should be more what to say, simpler. Features are simpler things. Okay, let's consider this cat versus dog. Okay, presence of triangular ear shows presence of a cat. Okay, now what will happen in your image? Now I'm going to draw a cat. I know you guys are going to laugh a lot. The cat can be like this, the cat can be like this, the cat can be like this, right? I mean, yeah, the cat can even be like this. Mane, cat can be in any of the positions. It can sleep, it can stand up, it can be falling down from somewhere. But the presence of the triangular ear is a feature of cat being in the image, right? It is not mandatory that the triangular ear should always be at the top region of the image. No, right? It can be present anywhere and with any dimension, right? It can be straight like this or tilted like this, anything. But if it is present, then it is cat. So for image classification, we are not mostly bothered about where is the features present. So for this kind of model, max pooling is the thing. Now there is another kind of thing called image object detection. So what happens in object detection? So if you say that there is a cat in the image, you also need to mention, you also need to make a boundary around the cat, that okay, here is the cat present. So you will be doing two things. First, telling me that okay, here one object is there which is cat, and you will also be telling me where is the cat in the image. This is called object detection. Now here, the presence of the triangular ear, the location of the triangular ear becomes important for me, right? Because that location can tell me where is the cat in the image. So in this kind of thing, average pooling will be used. So where location of the filters are important, average. Where location are not important, only presence or absence important, then max pooling. Okay, so this is the thing with it. Now after max pooling, after pooling, whether it be max pooling or average pooling, then comes our fourth and the final layer of the convolution neural network, which is fully connected layer. And you know what these layers are? This thing, these things over here, the dense neural network part. Okay, so what happened over there, uh, whatever the result is, you first of all need to pass it through a flattened layer. Okay, a flattened layer. Whatever the result is, if you want to pass it to fully connected layer, before passing it to a fully connected layer, you will have to pass it through a flattened layer. What flattened layer will do? It will convert it to 1D thing. 1D thing. Why? Because your fully connected layers does not accept 2D, 3D input. It accepts values only in 1D. So if there are things like this, there are multiple channels. This is a 3D data. So flattened layer will convert it to 1D. So what will happen? Let me just have a single example over here. Actually, all these things are written well in the handouts. So when you go through the handouts, do go through the handouts because their things are explained very well. So let's say there are one, two, three, four, five layers, five channels here. So what flatten will do? First of all, for the first channel, 0.95, 0.73, mane this, then this, then this. Four values are there. Then comes the second channel. Let's say the second channel looked like this, 1023. So the values will be 1023. Then like this, all the values will be opened up and stored like this. Okay, so here this thing is a 1D thing and this thing also 3D thing. So what flatten layer does, it just converts, it just reshapes anything into 1D. Why do we need to apply flatten layer? Because we are going to apply fully connected layers, and fully connected layers accept only this 1D data. Now just give me 10 more minutes. Maybe we'll have the break from 7:35 to 7:55, but let's just finish this part. So this fully connected layer is the same as the dense neural network. Okay, the thing we studied last day. Now, whatever input you have got using the using the flattened layer, you will send this thing to the network, and here you know how the values will be sent, right? Each value will be sent to each neuron in the next layer. Now, what will be the task of these neurons? These neurons will be combining these values non-linearly in a complex way. It can be x1 plus x2, it can be x1 into x2, it can be x1 square into x2. Somehow the layers will be combining these values all together, and finally there will be multiple layers so that these feature values. Now let me tell you one more thing. This thing which you're getting over here is holding the feature from the image. So this thing, the result of the what is this called, flatten layer, the result of the flatten layer is called the feature vector. Okay, the result of the flattened layer is called the feature vector. Now, when this feature vector is sent to the dense neural network part or the fully connected layers, then these are the features present in the image. The layers before this part actually extracted the features out of the image, and then it was present to you like this. Okay, and then what the fully connected layers are doing, they are interconnecting or correlating the features together to give you a final output, and this part we have already seen. Now let me just take you to the to one drawing which I made. If you remember, I told you in case of unstructured data, you have some part and then you have the dense neural network part. Why? Because dense neural network part is capable of working with features, right? But in general, unstructured data does not have features discretely mentioned. So some part will be extracting the feature. Here multiple convolution layer and pooling layer will be giving you that feature vector. Okay, once you get the feature vector, these vector, let's say the size of the vector was 10, the length, so x1, x2, x3 up to x10, these features were representing the image. That means your image is now represented by these 10 values. Now these features are sent to the dense neural network part and you will get your result. How will you get your result? Definitely you will have a y hat value, then a loss calculation will happen, and then it will go to each of the layer to update the parameters and everything. By the way, did you guys notice there is no parameter in pooling layer? Because you're just doing some calculation, right? You are doing just some calculations. You are not, uh, what to say, there are no parameters actually. So during back propagation, nothing happens in the polling layer. There are no back propagation happening in the polling layer. So this is what happens. There is a small recap. CNN is used to do two things. First thing, feature learning. As images are unstructured data, first of all, you need to extract the feature. And then on the learned features, the classification will be happening. So you a normal CNN will look something like that. See, it is just an example. Okay, not mandatory. You'll have to copy this architecture exactly. So here, see, the input is there. Then there is some convolution plus ReLU layer, then there is this pooling layer, then there is this convolution plus ReLU layer, then there is this pooling layer, and then after this there is this flattened layer. Okay, and after that fully connected layer, and last may this is also fully connected layer. Why softmax is mentioned, I'll come to it when we do the project. Okay, but this is the thing here. Just see, whatever was before flattened, there was a combination of different convolution pooling layers. It's up to you. If you want, don't even use any of the pooling layer, just use four convolution layers. It's up to you. Sorry, up to you. Use two convolution and then one pooling layer, so you can design the architecture as you want. But this part would be responsible for taking the image and giving you out some, what to say, features. Okay, then this is converted into 1D. So this thing is called the feature vector. Now dense neural network, as we know how it works, so it will work on the features and it will give you a result. So this is what happens in your CNN. Okay, so why the name is given according to the convolution layer, like of course pulling layer, pulling neural network, we are not calling it, we are calling it convolutional neural network, because the most important thing is being done in the convolution layer, right? Feature extraction, for feature extraction, filter learning is the most important thing, and that is happening in the convolution layer. So this makes the convolution layer most important one. Okay, so this is basically what happens in the CNN. We will be making a model right now, so things will be pretty clear to you. But still, if you have some doubts, let me know. Okay, now uh, this thing we have already seen, but let's just have a recap. What happens during the training? Input is sent. This rectangle is the model. Okay, input is sent to the model, then forward propagation happens, and one predicted output is given out by the model. Then this predicted output and the actual output are sent to the error calculation part. Error and loss are the same thing. Okay, and then this error is back propagated to your model. This error is back propagated to your model, and finally you get, like, what happens here, the values are updated. This keeps on happening again and again, so that your model learns the optimal values of the parameters. Okay, so let me know if you have any. Yeah, I can explain softmax, but I will explain it during the project, Adriel, just after the break. Acha guys, let's have a break from 7:35 till 7:50. Okay. If you have any doubts, you can ask. But if you do not have any doubts, then we will resume by 7:50. And Adriel, I'll be talking about softmax in a while. So we will resume by 7:50. Okay, I think we are good to start now. I have a question from Vishal. Why the number of I think we are good to start now. Sorry for that again. Uh, why the number of channels in filters and images are same? Now, the channel of numbers of filters and images. Let's say you have image with three number of channels, okay, and now if you put one filter with only one channel, what will happen? This filter can go to this place, okay, but instead what we did in what happens in convolution layer, the number of channels of the image and the number of the channel of the filter remains the same, so that each channel of the filter can go to each channel of the image separately, work on that channel and can give you one result, some results, and the result of all these three filters are combined together, and in the output they are put at one place. Okay, now if any one of them is more than the other, let's say you have three images, three channel image, and you have only two filters. So the filter can be put in the red channel, in the green channel, but what will happen to the B channel? How will you extract the feature from the B channel? No ways, right? That is why this does not happen. And on the other hand, let's say there are four channel filters. One, two, three, four. So the first three will be used for RGB, red, green, and blue channel. What will you do with the fourth channel? Again, for any matrix operation, matrix operation, when you do element wise operations, then your number of channels should be equal. Number of channels, height, width, everything should be equal. Okay, number of channel, height, width, everything should be equal. So if there is any inequality, it is going to give you an error. Secondly, there is no reason for having an inequality. Okay, so now I will move to our first project, and I was waiting for this for a long time now. So this project is going to be about face mask detection. That means you will be shown some images of people wearing mask or not wearing mask, and your model need to decide whether the person is wearing the mask or not wearing the mask. Okay, so according to the problem statement, this is first of all a binary classification problem. Secondly, a person like we later on you will. Acha, by the way, this is a project which we will be using along with IoT later on. Okay, this is not just it. इसके बाद we will be integrating it with IoT. And by the way, from tomorrow onwards, we will start the IoT projects as well. By the way, coming back to this thing, so here you will be operating from your laptop's webcam. If the person in front of the laptop webcam is wearing the mask, then it will detect as the mask is there. If not, then it will detect mask is not there. By the way, your webcam is just a camera source. You can use any other camera source if you want. Okay. Now, again, because camera source, that means images. Okay, images are coming along, that is why we will be going towards deep learning, because images are unstructured. So it is a binary classification where I'll be using deep learning. Now because images are there, that is why I will have to go to CNN, because CNN is the best model to understand your images. Okay, now a very important question people can ask you, can't we use completely DNN, dense neural network, in our in case of images and everything? We can use, but there are some problems if we use dense neural network for image understanding. And to know what that problem is, you can check out the handout. Okay, there it is mentioned, so I think you will get your answer from there. Now, coming back to this is a image classification, a binary image binary image classification, for which we will be using CNN. Okay, fine. Now we have understood our problem statement. The next thing would be data gathering. I have given a link. I mean, a link is given to you from where you can get the data. Okay, if you don't. if you have not downloaded the data till now, just 1 second. Mm, yeah. If you haven't downloaded the data till now, what you will have to do, you will have to go to that link, download the data, then put that in your Google Drive. Okay. Just let me show you one thing. Mm, yes, here it is. So this is the link from where you can get your data. I think you have got the link in your mail directly, but if you have not, then you can take it from here. It is present in the handout. So you will have to download the data and put it in your Google Drive. I have already done that. Now this platform where we are using, where we are coding for machine learning, this is called Google Colab. What you will have to do, you have already also got this IPYNB file. Okay, so what you will have to do, just search for Google Colab like this. Google Colab. What is Google Colab? It is a place where you can run your machine learning or any Python program. By the way, open this one, the first one. Okay, machine learning or Python program. This is a cloud-based IDE. That means whatever you run your model, it is running on some cloud resources. Now from here, go to this part, upload. Okay, either this kind of thing will appear or you will directly be sent to this part here. Just go to file and upload notebook, then choose the IPYNB file which I have sent you, this particular one, ISB IoT plus MLP1. Okay, and then you'll have to open that. I'm not opening it because I have already opened it over here, and this is what the file looks like. Once you have opened the file, now what happens over here, you can uh, uh, like what things you're getting over here. First of all, the IDE, it supports Python. So once you open your notebook, here will be a connect button. You will have to click that. See this connect button. Once you connect that, click that, then what happens? You are connected to one, like there is a link between Google Colab server and your account. See this account, your Google account, the way you have a Gmail, the way you have Google Drive, the way you have Google Photos in your Google account, you can also have Google Colab in your Google, from your Google account. Okay, no downloading, nothing, nothing is required. Now, once you click on connect, this thing is, there is a connection built between your account and Google server, and then yeah, your account and sorry, yeah, your account and Google server. And once the connection is established, you get a RAM of 20, 12.69 GBs and a disk memory of 68.35 GBs. Okay. Secondly, generally it is, if you run the program with this thing, it is going to run on your system CPU. Okay. But if you want to use any GPU, just go to this runtime, change runtime, and initially it would be set as none. You will have to convert it to GPU. Now as you can see, this is a hardware accelerator. That means if you're using your CPU, if it takes 2 days to run your program with GPU has some extra processing power. uh, I'll not get into much details of it, but if you require 2 days to run your program on CPU, with GPU you will be able to run it in maybe 4 hours or something like that. So it reduces the computation time for you if you choose CPU for your model running and everything. Sorry, GPU. By the way, what is GPU? Graphics processing unit. Okay. Now, so after you set up all these things, you're good to start the programming. Okay. So the first thing, you have put your data set in your, you have an old laptop, no problem, Imtiaz. You can still connect to Google Colab. Google Colab doesn't require much of the system resources. Only thing, it would be good if you have a camera in your laptop, because we are going to do some projects based on camera input in IoT as well. Okay. Anyways, so you have your data set in your Google Drive. Okay, so you will have to connect your Google Drive with your Google Colab. Acha, by the way, this thing is called a notebook. Wherever you're writing the code is called a notebook. The extension of this file is .ipynb. Okay, .ipynb. Here you can put any other name if you wish to. I have given the name ISV 2.0 IoT plus MLP1. It's up to you if you want to rename it. Anyway, so now to acha, one more thing in Python, what happens when you code? You Python is a language of libraries. To be honest, that means if you're coding in Python, you will not have to write a lot of codes because you will have something or the other library related to that task. So what you need to do whenever you use a library, what is a library? Library is a block of code which is already written by someone, but it is made available publicly so that anyone can access that, use that particular code, not access sometimes, but can use that particular code. So that if there is a code where there are 500 lines written, okay, and this person has made this as a library and this has been made available to you, so you will have to just import it in your first of all install it in your device, the library, and then import in your notebook wherever you are working, and then you can use any of the uh, part of the code of this library. We will know about this later on. As we progress in the coding part, we will get to know about it. So here we need to mount the drive. For this, either you can run this particular code or you can click on this particular button. Okay, if you click on this particular button, that also works sometimes. So here from google.colab, I'm importing drive. Drive is a library. Drive is a Python library which handles the linking of collab with drive and other things related to drive. Okay, then drive.mount. What is meant by mounting the drive? That means you are making a connection between your drive and your collab. So your um, yeah, whatever is there in your Google Drive will be made available in this particular notebook, and you will be able to access those things from here. So once you do that drive.mount, after that you need to give a location where you want the Google Drive, your drive to be mounted. So what is this slash content? The way in your devices, yeah, let's just go to this thing, desktop. In your device, the location of the root file is what? C colon slash user slash shweta slash desktop ऐसा करके, right? So here also the root directory is content, and this drive would be a folder created over here. This place over here, see, this is your file location. See, files. Okay, this place has address content, and content slash drive means a folder named drive will be created over here, and your actual drive will be attached to your collab and will be stored in this folder. So let me run this. So to run this, what you need to do, you need to only click shift enter. Just go to this cell and then click shift enter together. Or what you can do, there is this button, you can also click on this button to run the cell. Okay, now what happens over here? Here you will have to authorize that, yeah, you are allowing this connection, so you'll have to go to this link, and whatever account you have put your data in, just sign in through that, to that account. It will give you a code. Just copy the code from here, go to this place and paste it over there, and then run it. It will work for you. Okay, in just a while, you will see that my drive is uploaded here. Oh, sorry, mounted here, not uploaded. See this drive. If I open it, my drive, so I have all the contents of my drive. Okay. Now I have put this particular data set in my file only. So let's just check the path, copy path. So it is present in my drive, but I can access it from here. See, the path is content, drive, my drive, face mask, detection zip. You will need this file. See, .zip money, this is present in compressed form. So if you want to work with it, you'll have to unzip it. So to unzip it, you just need to do this, colon unzip, sorry, exclamation mark unzip. It is a shell command which works over here as well. This, after that, whatever file you want to unzip, just put the path of that file. Then hyphen D money, now you're going to put the destination of the content, location of the destination file. I mean, whatever unzipped files will be created, that will be stored in which place. So I'm just giving content money. I want them to be stored at this place only. Okay. So let me just run this. This is going to take some time because it is having 10,000 plus images. So let it get completed. Okay, so it is done. Let me just refresh this and see. I have got this folder face mask dataset. Here I have three subfolders: test, train, validation. In train, I have two subfolders: with mask, without mask. In with mask, what is there? Because there are a lot of images, that is why it is taking us some time to open up. Yeah, see, there are different images, and you can see these kind of images are there. Okay, people wearing masks. And if I go to the other folder, here also you will be getting different. Okay, I'll wait for a while, Megha. And here you'll be getting this particular, here also there are multiple uh, images present where people are not wearing masks. Okay, so here you have two classes, and from here you must notice one thing. Whenever you work with binary classification, or let's say there are 10 classes also, you should have one folder for each class where the images related to that folder, that class is present in this folder only. The name doesn't matter really, but yeah, there should be, let's say if there are, just say if we want to make a alphabet recognizer, so there are 26 alphabets. So for that, in your train data set is present in your train folder, right? In your train data set there should be 26 subfolders, each for A, B, C up to Z. Okay, so this is a way of sending data to your model. How did you upload the data set? Why C drive got loaded instead? First of all, data will be downloaded in your C drive or what's the location, let me, some location of your device, and then it you will have to put it in your Google Drive on your own. It will not be directly downloaded in your Google Drive. Okay. Now, now what happens? Now I have my file unzipped here. Now, there are some libraries where TensorFlow is the main one. TensorFlow is a Python library uh, which helps you in dealing with the deep learning thing. So whatever you want to do in deep learning, TensorFlow is the library. If you want to create a model with convolution layers, TensorFlow. If you want to create a model with dense layers, TensorFlow. Whatever you want to do, TensorFlow is the library. So I'm importing TensorFlow, and as TF means I'm giving a nickname to this library. Okay. So import TensorFlow as TF. So wherever I would be using TensorFlow, instead of writing TensorFlow, I can use TF. Secondly, there are some other classes or libraries as well present over here. So as I keep on using them, I'll explain what they are for. Okay, as I use them, I'll explain what they are for. Unzipping, for unzipping, you just need to run this particular cell. Colon unzip means you're giving a command to unzip a file. After this, you will have to put the location of your this data set. So you just go to drive, my drive, or wherever you have stored your data set. Just go to that place. Where did it go? Yeah, this particular file. Right click, copy path and change over here. If you think that your path is different from mine, people who generally upload in my drive do not need to change the path, but this path is for the zip file. Then hyphen d mane you're going to give the destination path location. Uske baad you can give the destination location over here. Okay, so it will be unzipped at the given location. Okay, so I told you these libraries, I'll be speaking about them once we work with them. So right now I'm just closing it from there. This is the place where you'll be getting the files. Okay, now here I'm just defining some variables, okay, which I'll be using later in my program. I'm keeping image width and image height as 150, 150. Again, you will ask me why 150, because this is a decent size. If I keep it 80, 90, it will become a bit smaller. If I keep it 200, 250, it will become a bit larger. So I prefer to choose 150 cross 150. You can choose 160 cross 160, 170, 170, whatever you want. What this will be used for, I will come to it. Now, this is going to, it is actually holding the path. See, here you have the training data set, right? The folder. If you copy the path, I'll just add one more cell by clicking this code. See, this is the same path. So actually, I have given this path a name, train data directory, and this path, this is for this validation data set. This path, the validation data directory. I think we have not spoken about the validation process, so I will come to it once we reach to the training part. Okay. Till then, let's just work ahead with it. So here what I'm doing, I'm initiating image width as 150, image height as 150, then train data dir, whatever the data, whatever the directory was, I'm just storing in this, and whatever the validation directory was, I'm storing it as validation data directory. Okay. Okay, next what I'm doing, I'm declaring the input shape. Here, I'm declaring it as a tuple. What is tuple? Tuple is a data type. The way you have integers, float, characters, similarly, you have tuples as a data type, which can hold multiple data at the same time. So here, actually, what the value will be held here, the value would be, let me put a comment here, the value would be 150 comma 150 comma 3. Actually, what happens when you get your data set of images, then your images can be of any different shape, right? It can be of 120 cross 130 cross 3. Other image can be of 200 cross 120 cross 3. So different images would be of different sizes. But you cannot send different image size to your model, okay? So what you need to do whenever you are working with the images, you will have to make all of them of the same shape. Okay, so that is why you'll have to reshape all the images in the same shape, and right now I have decided that I will be reshaping them into 150 cross 150 cross 3 3 because it is colored image. What is epochs, what is batch size, I will come to it, but just remember I have set the epochs as 50 and batch size as 32. Okay, let's just run this now. Now, this thing, which is a very new thing for you, data augmentation, but this is related to something which you have heard about, data pre-processing. So let's first try to understand what data augmentation is. Simply speaking, data augmentation means Simply speaking, data augmentation means that you are going to create fake data out of the from the data you have. Okay. Now, why would you want this? First reason, because if you have less data, so first thing, there are not much variety. There are not much variety. So only specific things are there. So your model will learn those things, not actually learn, but memorize those things. Because your data is less, okay, model will get the chance to memorize those things. And then here your model will be biased towards those specific features. For example, let's say you have some dartboard images. Okay, and out here only 100 images are there, and out of these 100 images, 90 of them has a red circle. Dartboard, I hope you guys know where you put, where you throw an arrow. It's not an arrow, actually it's a dart, but you throw the dart and it gets stuck on the board. So let's say out of 100, 90 of the images had this red circle at the center. Only 10 of them were of different circle, maybe blue or maybe colorless circle. So because there are not much variety, your model will think that okay, this red circle is also a feature of the dartboard. So to recognize any board as dartboard, their model will start searching this red circle. But we know this is not always the case, right? So here what happened, for this example, your model became overfitted to this feature. That means your model has memorized this feature and it is going to look for this feature in the test data set. So what happens? It might happen that in your training data set, your model is performing good because all of them are having these red circles at the center. So model is very well knowing that these red circles are for dartboard. So the model is saying that, yeah, this is dartboard, this is also dartboard, this is also dartboard. You're getting an accuracy of let's say 98% during the training process. But when you're testing your model with a dartboard with maybe with yellow circle maybe at the center, your model does not recognize this as data code. Okay, so this might give you an accuracy of maybe 73%. So see, your model performs so good with your data set, training data set, but during your testing time, your model could not perform so good. So this is a classic example of overfitting. This is very simple to what must have happened to each of us. When we are in class, we are understanding everything and we are actually memorizing everything. Okay, but if we just memorize and we do not extract the pattern, so what happened when we sit in the exam, if similar question or same question does not come, we cannot answer the questions, right? And then what will happen then, we will during the class our performance would have been very good, but during the exam it would have been gone completely down. So here also similar thing is happening. During the training it is performing good, but during the testing it is not performing good. So this all happened because the data was less. That means there was no variety of data. So if your data is less, the simple solution to this is that you will have to increase the number of data, right? You will have to extend your number of data. So it is not always possible to go to the data source and ask for extra data. Let's say I give you the data, you ask me, okay, I think your data is less, please give me extra data. I will be saying, I have this one only. If you want to work, or let me go to other engineer. Okay, so what happens, we create fake data out of the data we already have with us. And this process of creating fake data is called data augmentation. Okay, data augmentation. So here, the fake data, how what things can be done to create fake data? Let's say you have this image of a tree. Okay, so here you can apply various things on this tree image to generate other images of the same tree but with different view. Just note this thing down. Various images of the same from the same image of the same object but from various views. Okay, so I can rotate it. Okay, I can make it something like this. Okay, I can flip it, mirror image. So this will become something like this. I can vertically flip it, so it will become something like this. Okay, I can shear it. Shear is what? Okay, if you rotate a square by certain degree, chances are there you will be getting a kite like this. But if you apply shear force, so the base remains there, but the other portion of the object moves. So this creates a rhombus. So this is the difference between rotating and shearing. So let's say you applied some shearing and you got this as the result. Okay, so what is happening? You can apply various image conversion operations on the actual image to get these extra images. Apart from this, you can also change the brightness, you can change the contrast and everything. So what will happen? Let's say if you apply 1, 2, 3, 4, 5, 6 uh, uh, operations in the image, you will be getting 6 image from one image. So if you have 10k images, you will be getting 60k images after the data augmentation part. Okay. So we will now see how do we create this kind of data augmentation. So here what happens, you are going to use this image data generator class for your data augmentation. What is this image data generator class? This image data generator class, you see, you imported from this place. TensorFlow Keras preprocessing image. I mean, you went to TensorFlow, then inside that you went to Keras, inside that you went to preprocessing, inside that you went to image, and from there you imported image data generator. So let me just open this once for you. Dot image data generator. So it's always a good idea to read about the things you're using. Okay. So see what this does. Generate batches of tensor image data with real-time data augmentation. Batches of tensor image data mane at a time 1632 batches like this many data will be generated. Real-time data augmentation, at the time you will be training your model, that time data will be generated. Before that it will not happen, that data will be created and it will be stored in your location, then during training it will be used. No, when you will be training, at that time only it will be generated. Okay, so let's look at the things we can do here. See, these are the various operations which you can apply. Okay, just look at few of them: vertical flip, horizontal flip, rescale, then fill mode, then zooming, then shearing, then brightness changing. There are so many things you can do with it. So I would appreciate you guys if you go to this link. You just need to search for it over Google, as I did. See, I searched for this thing, tensorflow.keras.preprocessing.image data generator. Go to this place and check out what are the things which you can do with this. Okay, so coming back to this, what I am doing with it, I am applying rescaling, shearing, zooming, horizontal flip. Let's start from the basic. What you need to do here, you are actually, image data generator is a class. Okay, so you will have to create an object, and that is what I'm doing here. I'm just telling this data, train data gen, I'm creating an object of image data generator, and I'm telling what things needs to be applied whenever data generation or data augmentation will be done. Okay, so here what things I'm applying, I'm saying ki I want horizontal flip, I want zooming by 20%, I want shearing by 20%. What is this rescale? I hope you remember the normalization thing. Whenever you're working with images, you will apply the normalization process, x minus minimum of x by maximum minus minimum, which as I showed you comes up to be x by 255. Okay, that means you will have to divide every pixel by 255. Why we are doing this? We are doing this to bring the values in the range of 0 to 1. Okay, because in your images, because the lowest and highest values are 0 and 255, values can be of any range. It can be in 0 to 10, it can be in 25 to 50, it can be in 50 to 80, it can be of in any range, right? But we want them to be in a small range, so that the lesser the number would be, whenever the filters are going to be working with the image, I mean, convolute with the image values, they are going to be multiplied here. Okay, so the lesser will be the pixel values, the less time would be taken by the CPU to multiply it, the processor to multiply it. That is why we want to bring the data in the range of 0 to 1. So this is just to shift the range. Okay, just to shift the range. So whatever values were there in the range of 0 to 255, I want them to be in the range of 0 or 0 to 1. And for that, I am going to apply this particular function, which will be, which will need me to divide my pixel values by 1 by 255. Okay, so these are the things I'm going to apply. Now, mind this, I'm going to apply. Right now, these will not be used. Here, I'm just creating a data generator, and I'm telling the data generator, see, whenever the data augmentation will be done, you need to use these things. Okay. Then the second part over here you told what operation needs to be done, but later on you need to tell this data gen from where it can get the images on which these uh, operations will be applied. Okay, so here we have train data gen dot flow from directory. Yeah, 1 and 1 is same in Python. 2.0, that means the previous version of Python, they both had different meaning, but now 1 and 1, they both are just the same. Okay, so if you want to study more about it, as I always would ask you to do for the next few days, so you just go to Google and search about it. So keras.io, here also you can get the information of the function, and the function is flow from directory, right? Flow from directory. Now see what this function, acha, here there is no explanation actually. No, there is some explanation. Yeah, flow from directory. What this method does, takes the path to a directory mane folders path, and generates batches of augmented data. Mane it will go to that folder, takes images from there or augment them and generate new augmented data. So here train datagen dot flow from directory, you need to pass the folder of the data set which you will be you want this data gen to work on. Of course I'm doing this for training data set, so I'm passing this particular path. As you remember, I just stored this path, the path of this folder in train data did, so this will be passed here. Okay, now other things are also there, that okay, it will be taking the data from this particular directory, applying all these operations. Then what will be happening? Then all of these data would be reshaped into this shape, whatever I'm giving. Okay, target size means after augmenting, all the images will be shaped in this shape. This is width and height only. So, and then it will be coming out as the generated batches. Okay, now, batch size is what? Batch size is at a time how many batch of data you want to have. So, what actually happens? We don't really work with singular data, we work with multiple data at a time. Okay, so what happens? Let's say you have this particular thing, it is your overall training data set. Okay, out of this, you said you want to have a batch size of 16. That means 16 images would be taken. Okay, 16 images would then be sent to the image data generator part using the flow from, dot flow from directory. Here on these 16 images, first of all, they will be sent to the train data gen, which you have created, where you have mentioned what operations you want to do. Then on these 16 images, the operations would be applied. Okay, so you will be getting various rotated, flipped, and images like that. After that, all the values would be rescaled. Okay, so again, here you're getting these values. On the rescaled values, now the reshaping happens, which is nothing but your target size wala stuff. And finally, the reshaped data is there with you, which you can send to your model for training purpose. So starting from 16 images, it might become 64 images here, and these images will be sent to your data model. Now, what happens after that? We will be coming to it in a while. Okay, but for now, this is what is the meaning of batch size. Batch size means at a time you don't want to work with a single data at a time. You want to work with a lot of data. So we generally put the batch size as a multiple of 2. So 16, 32, 64, these kind of batch sizes can be given. You should not put a very high batch size. Why? I will be coming to it just in a while. Okay. So just it would be better if you keep the batch size lower than 128. If you go beyond 128, there are chances that your RAM memory will crash. What is the reason? I will come to that. Okay. Now, what is the meaning of this class mode binary? I have told you in the previous class that your model does not understand any language, right? Right now, what is the name? What is the labels? The labels are with mask and without mask. These are the Y values, right? The actual output. Now, using the Y value, your model needs to find the loss value, right? Which happens after the forward propagation, Y and Y hat value. Now, in the loss value, when it is supposed to get the loss value, it will be doing some calculation only. That means it needs some numerical value. Here, your with mask or without mask are not going to help your model in understanding what the class is. So that is why these value needs to be encoded. Encoded money, they needs to be converted into some value, some numerical value, which are not the actual value, but somehow representing the values. Okay. So here, what will happen? Because you have said binary, so one of the data, one of it will expect two classes to be there or two folders to be there. Okay, here there are two folders. Now there are two folders, one is with mask, another is without mask. Okay, with mask and without mask. Now, alphabetically, which is coming before, so this will be coming before, so this will be given another number 0, and this will be given a number 1. Let's say you had two classes, cats and dogs. Okay, the folder names were cats and dogs. So definitely alphabetically cats come before dogs. So cats will be replaced by 0, and I mean a new encoding will be done. Cat will be encoded by 0, and dogs will be encoded by 0. This method of encoding is called label encoding. Encoding. Okay. Another type of encoding is one hot encoding, which we will be seeing in some other project. Okay. One hot encoding. Anyway, so that your model can do the encoding, that is why you have mentioned a binary over here. Okay? If you would not have mentioned binary over here, then it would have been a problem for your model to understand how to encode the values. Anyway, so basically what happened in this cell, you first of all decided what operations you will be applying, and and secondly, you are letting this generator know from where it needs to get the data, what would be the target size, the batch size, and everything. Okay, so just run this. This will not do anything. This will just recognize that okay, in this folder there are two classes. That's all. There are 10,000 images belonging to two classes. This will not be applied right now. So for validation dataset also we are going to do the same thing. What is validation dataset? So just a second. So in your let's say you have this is your overall data set. Okay, so you divide this data set in two parts, one training and another validation data set. Why? You have the x and y values over here and x and y values over here as well. So you send this training data set where x and y both are going in your model, forward propagation is happening, and then loss is being calculated, and then back propagation is happening, and during the back propagation your model is learning stuff. Now you want to validate whether your model is performing fine with any other data set as well or not. In that case, you will use your validation dataset. Why? You have separated this dataset. That means your model is not trained on this dataset. So this can be treated as a never before seen data. Okay. Then here also some x and y values are there. Your model is then going like this x and y value will be passed through your model. So forward propagation will happen, and then loss and accuracies, these things will be calculated. No back propagation will happen because your only learning happens in the training phase or the training with the training data set. This validation is just to check model's performance on any other data set. So it is just going to have forward propagation and loss and accuracy calculation. That is all. Nothing apart from this will be done with the validation data set. Okay. So we already have our data set in two parts, train and validation, so we do not need to make any separation here, but here you will have to work with them at the same time. So here what happens, because for the learning we want variety to be there, because we want our model to extract as much features as it can. That is why what happens there, you do not need any learning in validation data gen, right? You're just using it for training, sorry, checking your model's performance whether it is good or not. That is why we do not apply any operation, augmentation operation here. We do not need to create any augmentation here. Okay, so here what happens, you simply uh, uh, use rescale, because rescale is always going to be something you will always be using whenever you're working with images, and you will be seeing this from here till the end of this IoT with ML week. Okay, so you'll always have to rescale and see other things are just the same as we have our uh, train generator, you have your validation generator. Only difference here, you're changing the data directory. So once you do this, see there are 800 images belonging to two classes. That means 10,000 images are there in your training data set, and only 800 images are there in your validation data set. Okay, so this is the thing over here. Once you're done with this, that means you have created the data augmentators ready. Okay, and what you need to do now, you need to create a model. It's like your data is ready, although nothing has happened now, but your data is somehow ready. Now you need to build the model, and your next step would be sending the data through your model. Okay, so let's go to the next step, which is building the model. So here I need to talk about one more thing, which is transfer learning. Now let's just take one example. You guys know how to ride a cycle. Okay, so once you know how to ride a cycle, you know how to balance a two-wheeler, right? You know how to move your handle if you need to turn, right? Because in car you move the steering wheel, not the handles. You know from uh, how to pass yourself from a narrow space or things like that. Now if you know riding cycle, just think of this. Won't it be very easy for you to learning riding any two wheeler, be it a scooter or a bike? I'm a person who does not know how to ride a cycle, so I'm definitely going to take a lot of time to learn to ride a motorcycle or a scooter. But if you are a person who knows how to ride a cycle, won't it be a bit easy for you? Or won't it be less time taking for you? Of course, it would be, right? Why? Because you already have some training. You have trained yourself in order to perform a particular task. Now if you're going to perform a task which is similar to the earlier task, I'm not saying same, okay? Similar means some things are same, some things might be different. So if there is such a task, so definitely the earlier knowledge which you have from the earlier task which you know how to do, that is going to help you here. So what you do not start learning how to ride a motorbike from the base. Okay, you start learning the extra things. What extra things? For example, okay, yeah, in cycle you had to pedal it, but in bicycle you need to have some gain over the accelerator. In the bike you have to gain have some control over the clutch and everything. So you need to learn that. Now definitely motorbikes are going to be heavier than cycles, so you need to learn how to hold this weight, because you know how to hold a two wheeler, but the weight is different. Okay, so you know few things, but again you will have to learn some new things. But again, if you know something, if there is a base task which you already know, and your new task or the target task, learning bicycle, riding bicycle is your base class, learning how to ride a motorbike is your target class. So if you do the target task from the help of the base task, from the help of the knowledge you have got when you learned the base class, definitely it would be beneficial, right? So this is nothing but a clear example of transfer learning, where you have got some knowledge from doing a particular task. Now you need to do another task, but this new task is somewhat similar to the old task. So you transfer the knowledge you got in the first class to the new task. Okay, and whatever tweakings you need to do, you just put your concentration on those tweakings. You do not need to learn anything from the scratch. Okay, so this is the concept of transfer learning. Here I explained you this thing because I am using transfer learning. I am not going to create my model from scratch. Don't worry, I'll show you one example what you need to do if you want to create a model from scratch. But here I'm going to use transfer learning. So there is this model, MobileNet V2. If you want, you can search for it. It is a pre-trained machine learning model. It was trained over a image data set which had 1000 classes. Okay, 1000 classes. So it was trained over some classification model. See, this is what the architecture of this model is. See, it has input layer, then convolution layer, then bottleneck residual block. And this block had in it convolution, dense, convolution layers, etc. etc. This architecture is a bit complex one. I will not explain the whole architecture right now, because then again it will take you more time to understand things. But I will explain a small portion of a simple architecture so that you be able to understand any complex thing. Okay. And of course, if you have any problem in understanding the architecture, you can come to the class tomorrow during the doubt clearing session. So here I'm going to use this particular model. This is pre-trained. इसका मतलब क्या हुआ? इसका मतलब the parameters in this model, there were convolution layers, there were dense layers. So the parameters in this model, I have already gained the optimal values. Now I will ask, why am I using it? Because this model knows how to understand images. Of course, this model had 1000 classes, out of which it had to classify. So the dense layer will be working in a different way. But the feature extractor part, which was extracting feature out of the image, I can use that part, right? I will have to convert the dense layer wala part. I will have to have the dense layer part depending on what my use case is. But I can use the previous layers over here. So what happens over here, I'm going to use this MobileNet V2, but I'm not going to use it completely. Let me show you 1 minute. Yeah, this. I am going to use it till this part. If you can see, the last one is fully connected layer. I'm not going to use it. I'm going to only use the feature extractor part. That means till this part. So the fully connected layer, or anything from flattened till the output layer, is called the top layers. Okay. So basically, I'm not going to use the top layers. I'm only going to use the feature extractor part. So here what is happening? Yeah. Here I am just importing this MobileNet V2 from this place. Now to know what other models are there which you can use, just go to this particular library. Okay, tensorflow.keras.applications. You will see at least 7 to 8 types of models which are already pre-trained. So they are ready to be used by you. Only difference is they are all trained on images actually. Only difference is all of them are having different architecture. Okay. So you have this MobileNet V2. Okay. So once you import this, you need to load this. Okay. It's kind of loading the model. So here you need to mention few things. First of all, look at this thing, input shape. So this model was this model was trained by some other group of people. They made it available to us. That is why we are able to use it. Okay, it's not like a it's not like that it appeared from nowhere. It was trained by a group of people and they made it available to be used by anyone. That is why we are now able to use it as a pre-trained model or a base model. Okay, so you have to mention the input shape, the input shape which your images are going to have, because this mobile net v2 was trained on some other shape. So here you need to mention what shape you are going to send to this model. Okay, then you will have to mention whether you want to use the top layers as well. So as I told you, here the fully connected layers are not of my use. They are designed to classify 1000 classes, but I have only two classes, right? So that is why I'm not going to use this full the top layers. That means just before the flatten layer I'll have everything, but after the flatten layers I have nothing. Okay, so that is why I'm mentioning false. If you want to use the overall model from the beginning till the end, you will have to mention true over here. Okay, now this thing, weights. What is this thing? Now the pre-trained model is definitely having some pre-trained weights. Pre-trained weights mean some weights which are or which have already gained their optimal value, because those that group of people trained the model, so they have received the optimal value of the parameters. Now here I am going to load the same value, the parameter values which those people have trained the model with. I am going to take that particular file which has the model, the parameter values, and I'm then going to load the values to this particular model. Okay, so this model will come up with pre-trained optimal weights. Just think, I will not have to train my model how to understand images. The model will itself know it. So it is going to save you a lot of times. Okay. So here, if you want to, sometimes you might want to, not load the weight. So at that case, you will have to mention none over here like this. You will have to mention none over here. If you do not want to, what happened? Yeah. If you do not want to load any pre-existing weight, then you will have to mention none over here. But because I do want to have the weights, the pre-trained weights of MobileNet V2, I'm mentioning ImageNet. So what are these three arguments for? Here you are mentioning the size of your input image. Let's say you kept your image as 120, 123. So you will have to send it over here. Now, one question you guys could have asked, can't we put the height and width different? So you guys can put the height and width different, but if the image is of square shape, it is very easy for the model to optimize. Okay. Anyways, include top false money, you're not going to include the flatten layer and anything after that. Okay. Then the weights, you're saying you want to load the weight, and this is the keyword to load the weight, ImageNet. By the way, ImageNet is the name of the data set it was trained on. Once you run this, it is going to take some moment to um, get it done. Why? Because it is loading this model. See, there is this link, downloading data from, and at the end you see there is this .h5 file. We are also using this .h5 file later on in our image, in our model project. Okay, so this .h5 file, all the parameters are saved in .h5 format. So it went to this location. Okay, and in this location, from this location it downloaded the values. Okay, from this location it downloaded the weight file and loaded it in this mobile net. So if you want to see what layers are there in this mobile net, in this object which you just created, just do this mobile net dot summary and run it. See, you will be able to see what objects, what layers are there, what layers are not there, and etc. etc. Say this is input layer, this is convolution layer, then there are some batch normalization layer, then there is this ReLU layer. ReLU is also an activation function. Okay, so what ReLU does, uh, just give me one moment.
Yes. Yeah. What ReLU does, the way sigmoid pushes the value in the range of 0 to 1, ReLU is really different from it. Okay. ReLU, the function ReLU has is maximum of 0 comma x. This is ReLU. That means, let's say if your x is 5. So what is the maximum between 0 and 5? 5. So the output of ReLU would be 5 only. Let's say your input is minus 5. What is the maximum between 0 and minus 5? Of course, 0. So 0 will be outputting. That means ReLU, if any negative values are sent to ReLU, ReLU is not going to output them. ReLU is going to print 0. And the positive values will be sent as it is. Okay. So if you want to know about ReLU in detail, I will be covering it in tomorrow's doubt session. Okay. So for now, I'll be moving to the other part. And if you want to know more, if you want me to explain uh, about ReLU more, please come to tomorrow's doubt session. Okay. Coming back to the model, so here there are a lot of layers. So I would suggest, if you're not familiar to machine learning, don't just directly jump to this part. Okay, this part is a bit complex. I won't say it is really difficult, but it is a bit complex for a new timer. So just, I'll be sharing one more model with you. You just run that model and then see the summary of that model. Okay, how do you see the summary of any model? You just write the model name and then dot summary. Okay, now here what things are there? The layer names and what will be the output shape of that particular layer. Okay, then how many parameters are there in the layer, and what layer, what next layer this layer is, this layer connected to. So these are the information which you'll be getting in model dot summary. Because I asked you not to go through this, I'm also closing it right now. So what happened here? I had this mobile net. I just imported this mobile net model from there. Okay, just give me one moment. Huh? Let's just skip this particular part for a while. I'll come to this. Now, the mobile net layers which you already have, they already have some of already trained or pre-trained weights, right? Or the filter values or whatsoever. So I want to keep those values only. I do not want to change those value anymore. So for that thing, I'll have to freeze those layers. For if I freeze any layer, that means no backpropagation will be happening there. Now, because my model, in this part of the model, the part which I have loaded till now, because this is pre-trained, so I am just going to freeze this model. How can you freeze it? You will have to go to each layer of the net architecture, and each layer has this dot trainable variable. You will have to set that trainable variable false. So in the training process, whenever it is seen that for any layer the dot trainable is set as, the trainable variable is set as false, then that layer is a part of the forward propagation, but that layer is not a part of the back propagation. Okay, now what happens over here? Let me just show you what is held in mobile net dot layers. Then you will be able to understand what we are trying to do. Mobile net dot layers. See, it is returning you all the layers. Convolution layer, then you have this batch normalization, ReLU, etc., etc. So whatever layers were there in the mobile net, it is holding that. So if you do for layer in mobile net dot layers, it is going to access one layer, then it is going to set its trainable as false, then it is going to go to the next layer and set that trainable as false, and it is going to move to all the layers. So when you run this, just notice one thing. If you print this mobile net dot summary, so there are parameters which, acha, wait, I'll have to run this. Yeah. So when you loaded this particular model from here, okay, here, now when you try to see the summary, so what will happen, just go to the end. Here you will be seeing total number of parameters. There are around 2 lakhs, 2 million 223,000 parameters which can be trained here. But what we wanted our model 223,000 parameters which can be, okay, we wanted our model to be frozen. We don't want our model to train these parameters. Okay, you will say that, okay, we have already loaded the weight for these parameters. Why is it showing it to be a trainable parameter? Because even though they have some value, they're still eligible to be trained more, right? So that is why it is trainable. But as soon as I'll run this, you will see this. As soon as I'll run this, okay, and now just look at this number. Trainable parameters 2.2 million. Now, if I run this particular cell again, and if I go to the end, see, total trainable parameters 0. That means now my model will not be able to, like, there are no parameters which my model be able to train. Okay, so it is fully frozen. But if you remember, I told you that I'm only taking the feature extractor part of the model. Acha, let me know, do we have any doubts still here? Let me know, do we have any doubts still here? Let me know if you have any doubts still here. See, even if you do not have any doubt, it would be better if you mention that in the chat that no, I don't have any doubt, anything like that, so that I be satisfied with the thing that everyone is understanding everything, and then I'll be moving ahead, right? So why were the layers frozen? The layers were frozen because I do not want to train the layers anymore. Now I have two options to either train the pre-trained layers again. It will be like tweaking the values furthermore, matlab making the optimized value more optimized. Let's say the optimized value for mobile net was 3, but I'm making it 3.1 because I'm adding extra backpropagation in it. But sometimes what happens when you have low number of data, as we have in our data set, 10,000 is considered to be a low number of data. So for any lower number of data set, if you train the pre-trained layers again, so what will happen? It will get it. There are chances that it will overfit. Why will it overfit? Because they will try to again memorize, because it is already perfect, right? And you are making it more perfect, you are getting it more chance to learn, and during that chance you're giving it to learn, it will not learn it, rather it will memorize the features, so it will somehow overfit. So if you have small data in your data set, the number of data is less, then it is advised to not train your pre-trained model. Okay, so it is better to freeze your model so that there are no chances of overfitting, and then train only the newly added part which we will be adding right now. I hope that answered your question. No doubts, others. Okay, so as I told you, we have only taken the mobile, the feature extractor from the mobile net, but I still have to have a flattened layer and few dense layers. Okay, few dense layers. Lastly, I will have a single neuron which can give me the value either 1 or 0.
for mask or no mask, with mask or without mask. So now is the time when I add these layers to my model. Let's see how do we do that. Okay, so here I am creating an instance called sequential. So there are two ways in which I can create my models in TensorFlow. The first way is using sequential model. In sequential, what happens? Let's say I have a convolution layer, C and B. I have another convolution layer, C and B. I have another pooling layer, okay? And I have another convolution layer over here. So if I wish to, so in sequential means that the output of the previous layer will be sent in the current layer as input. Output of the previous layer will be sent in the current layer as input. So here I give the image img. Whatever is the output feature map, this will be sent to this one, this layer. Then the output of this will be sent to this one. The output of this will be sent to this one. And if there are no any layer after this, so this will be my final output y hat. Okay, this is meant by sequential. Other thing, let's say if you want to have two layers here, one convolution 1 and other convolution 2, there are two layers here, and you want to send the output of this layer to the two layers, and then you want to combine the output of these two layers together and send in the pooling layer. Okay, for this kind of thing you cannot use sequential, because sequential does not allows multiple output and multiple inputs. Sequential meaning ekdam simply one output, one input, the output of previous is the input to the current. For this kind of thing you can use functional API. Functional API. Okay, so functional API would be something, see, things which we are not covering in the project. If you want to learn about these things, you can come in tomorrow's doubt session. I'll be explaining what is functional API and what, how you can use it, etc., etc. But right now I cannot spend time over that. So functional API is something which allows parallel connections. So if you want to create model like this, you will be using functional API, and if you want to go with simpler model, you can use sequential API. Right now we will be using the sequential API to create the model. Now what happens over here, I'm writing sequential. Now what is the sequential? See, when you imported the libraries, you imported this sequential, it is a class, you imported this from this place. Okay, so, and see, there are these layers also imported, so you can use them anywhere you want. So yeah, once you create this, this means this model is now like a blank container. Okay, this model, once you write model equals to sequential, it's like a blank container is created, and the name of this blank container is set as model. Now what happens? You're saying model dot add. Model dot add, this dot add function is going to add whatever layer you use here. These layer or this or another model or whatsoever will be added to this blank container or this container. Okay. So first of all, I'm adding this mobile net. So anything from the beginning till the end, anything from the beginning till the end, mane till this layer will be added to this particular blank container. Okay, so when I write model.mobilenet, so multiple pre-trained layers will be added to this blank container. Now for the next thing, what I'm doing, I'm writing model.add flatten. Model.add flatten. So here another flatten layer will be added. So what will happen? The output of the mobile net will be sent to the flatten layer. Okay. Then I can use a single or multiple dense layers. Okay. Now here I'm using a single dense layer. Okay. So here I get the privilege of applying a dense layer right here. Okay. And here I'm setting the number of neuron as 1. Why? Because I want it to give me, I'm like, this is my output layer. As you can see, uh, there are no any further connection. There are no any further connection. So So it would be better if I, like, this is my output layer. Okay, in the output layer I'm setting the activation and sigmoid so that it can give me 0 1 wala output. Okay, so this is the thing over here, this is the thing over here. And here, if you wish, you could have added multiple dense layers as well. As I told you, creating the architecture is completely up to you. Creating the architecture is completely up to you. Okay, so this is my model's architecture. This is what I want to create my model as. So again, if you want to see the summary of this model, you can write model.summary and go to this. Here there are 32,000 parameters, and these 32,000 parameters are from these layers. Okay, are from these the last layer only actually, because we have set the parameter of the other layers as like we have frozen them up. So this is the thing here. After this, what happens once you create your model? Acha, by the way, just have a look at it. If you wanted to build a model from scratch, you could have used this kind of an architecture. I have commented it. If you want to run this, so you will have to remove three quotes from here and three quotes from here. See what we have done. We have, first of all, you'll have to tell the model whether it is sequential or API. So I have told here that the model is sequential. Blank container or this if the image is either of two classes, then what will be the model predict? Either of two is neither of two classes. The model will predict whatever the image, there would be some features in the image, right? So it will be giving the nearest class possible to that. Let's say if a cat and dog is there, and if you give a tiger, tiger resembles more to cat, so it will be predicting it as cat. Okay, so here, if you want to make your own model sequential, first of all, you need to mention so that a blank container is started. And like this, you can add the layers. Now, again, I would ask you to go through it, just see how layers are added, how they are not added. If you want to, if you want me to explain you this thing, then come to tomorrow's doubt session. Okay. Anyways, so till now my data was ready, my model is ready. Now what I need to do, I need to compile my model. Okay, I need to compile my model. What is the model compile? I need to configure my model. Model.compile is a process where I need to tell my model some training parameters such as what optimizer to be used. If you remember, we have seen the formula of gradient descent, but there are, as we have multiple activations, we have multiple optimizers as well. And here I'm using the Adam optimizer. If you want, you can read about, there will be multiple blocks about Adam optimizer and all. Adam optimizer, so you can read about the blocks and everything to know more about it. But for now we are just using it because either we mostly use either Adam or RMS prop. You can note these names, Adam or RMS prop. Now you're also mentioning what will be the loss formula applied to your model. Now this loss formula, let me explain it a bit. Binary cross entropy is actually something which looks like this: minus y log of y hat. Okay, minus 1 minus y log of 1 minus y hat. So this is the formula of binary cross entropy. When will this formula work? This formula, when will this formula be used? This formula be used when will be used when you're dealing with binary cross entropy. If you want me to tell you what other formulas will be there for other kind of models, again come to the doubt clearing session. Binary cross entropy. Now let's say your actual output was, let's say 0, but your model predicted is something, let's say 1. So how your loss will be designed? Because y was 0, see this whole part is completely switched off because a 0 will be multiplied here. Okay, acha, let's say your model predicted is as 0.5. Okay, now what will happen? This part minus 1 minus 0, that is 1 into log of 1 minus y hat, mane 1 minus 0.5, which is 0.5, right? So this is minus log of 0.5. Now what happens? Your model will try to minimize it. To minimize this function, your model, because there is a minus sign, your model will have to maximize this thing, log of 0.5. Okay. Now to maximize this thing, your model will have to minimize this thing, because logs, if there are any fractional value, then your model is actually yeah, if there are fractional values, then your model then log is going to give you negative values, right? So here the lowest your log can go is 0. So here it will try to minimize this zero point 0.5, and it will push this zero point 0.5 towards 0. So your y hat will come to 0. Okay. Secondly, if you are your actual class is 1 and your model is predicting maybe zero point 0.3. So that, then what will be happening? I'll not explain it completely, but when your actual class is 1, see, this part is completely being switched off. Okay, this part is completely being switched off. Okay, so here the formula of loss will become minus log of zero point 0.3. Now your model will try to minimize this. In order to minimize this, your model will try to maximize this log of zero point 0.3. And here you will see, to maximize this, you will have to uh, uh, make this maximum. Make this maximum. And to make this maximum, this zero point 0.3 will be pushed towards 1. And that is how your model will be sending y hat towards 1. Okay. So basically, this is your binary cross entropy function, and it has two terms. Any one term will be activated at certain time, and the other term will be closed. So this is how your binary cross entropy will be working. Metric is the accuracy which we are going to work with. Metric is the accuracy which we are going to. Actually, metric will be something which you want your model to observe. Okay, metric is something which you want your model to observe. So whenever we will be training, I would want my model to observe the accuracy, so that during the evaluation, it gets stored somewhere. Where it gets stored, I will be covering it in today's session when we will be completing this model. Okay, so this is the thing till here. You have you have created the model. You have created the model, you have worked with the data set. Now you have configured your model. Now the final task would be to train your model. Okay, and this is the final training process. Okay, this is the final training process. This is the final training process. Now here what is happening, see, I'll be leaving you at this point. After this point, there would be only 5-7 minutes task, but I would leave that thing on you. I'll be covering from here tomorrow. Okay. So, do we have any doubts till here? Do we have any doubts till here? Do we have any doubts till here? Okay. No doubts, Megha. Mm, okay. Okay, fine. So, as I was saying, this model.fit is the process which helps you in training the model. So here, what things you need to mention? You need to mention the train generator. You need to mention the total epochs you want to have. You need to mention the validation generator. And you also need to mention, okay, this thing need not be there. This thing, um, yeah, even if you don't give this thing, this validation step and this steps per epoch, these are calculated by the machine itself. So I'm just removing them. I'm just removing them. Okay. So this would be your training process, but before that, actually, yeah, it is better to understand what is this thing. Early stopping callback. Early stopping callback is actually going to help you in uh, stopping your model from getting overfitted. Okay, What is epoch? I'll come to that. I'll come to that, Imtiaz. Early stopping is going to help you in stopping your model from getting what to say from getting overfitted. Okay, so here what it is a kind of callback. Callback money during the training time. You can call this particular method anywhere. Now, what this method will do? This method will check your whatever monitor value you have given. I'm giving the validation accuracy. Val accuracy means validation accuracy. It will check if there are any repetition of this val accuracy, and if yes, so it will stop the process over there. Now you will be setting the patients and everything. So what these things are, first of all, you need to decide here what val accuracy is. Sorry, you need to decide what monitor you're going to have. Then you need to decide the monitor quantity, whether you want to minimize it or maximize it. For example, if you would use loss here, validation loss, your mode will become minimized because you want to minimize your loss. But here we are using accuracy, so we would be maximizing it. Okay. Then verbose one is just for display. Like there would be some display in the training, so I'll come to the training process. Then I'll be explaining this thing. Then we have this patience. Patience 2 means the model will be checking for 2 times. If the monitor, the validation accuracy, there are 2 times the validation accuracy value has been repeated. So for any third occurrence of the same value, the model will stop the model training. Okay. See, first time here, if you notice, my validation accuracy was 99, then 96, then again 99. Now, because there are 2 times 99 happened, my model training was stopped here, early stopping. Okay. And then restore best weights is to store the weights. Whenever this happens, the weight, if you write history, okay, the weight will be stored somewhere. Where will it be stored? I'll be explaining that when we'll be coming to the training part. But I'm not going to cover this today as it has already been the time. So what we have seen till now, we have seen everything except the training process and the model saving process. So I'll be explaining these things at the beginning of tomorrow's class, and then for tomorrow I'll be starting the IoT wala section. So let me know if you guys have any doubts till here. Acha, till the time I'll just mention what epoch is so that Imtiaz can sleep without any doubts in his head. So let's say this is your model. If you remember, there was a kid who was learning ABCD in our first class, right? So when you train any kid to learn, to remember, to recognize ABCD, it is never the case when you show the image, the book once to the kid and the kid will understand it, right? Not possible. You will have to show the book for, let's say, 30 times. Then only the kid will be understanding it. I'm just giving you an example number. So here, the kid is going through these examples 30 times and extracting patterns from them. So here, number of epochs is 30. Similarly, it is not possible that if your data set has 10K images, you will send the 10K images through your model and backpropagate. It is fine. But this means only one epoch is complete. When your overall data set is passed through your model, that means one epoch is complete. Mane pass through, mane both forward and back propagation has happened. Now, what happens generally, we train for multiple number of epochs, for multiple number of epochs, multiple epochs. Why do we train for multiple epochs? Because it is the way we human cannot learn anything by looking at one thing at once only. If you remember, I showed you guys how ka is written in Gujarati yesterday. So I don't think you guys remember that, right? Because you just saw that once. Similarly here, if I train my model with the data set for one time only, that means for one epoch, my model will be learning something, but that learning will not be enough. That learning will not be enough for my model to start predicting values. So that is why we generally send the overall data for multiple times. So that it's like the sending ABCD, showing ABCD multiple times to the kid. Okay. So that your model can extract the features in depth. Your model can extract the features in depth. So it is similar to loops, but in a different way. Yeah, it is similar to loops, but in a different way. And how is it different from loops? I'll be explaining it once we start our training process, which we will be doing tomorrow. So till now we are done with everything. We are only left with a single thing, which is model training. Two things actually: model training and model weights. Okay. So I would suggest you guys just to run this here. Once you start running this, like you go through all the cells, once you run this, it will take around maybe 15-20 minutes. Then run these two cells as well. Sorry. Then run these two cells as well. And then some files will be stored here. Okay, let me just show you this thing. Yeah. So I ran this file. If I refresh this, see this file is stored here. So just keep it downloaded in your device. So once I download this, this will be downloaded in my device. I'm stopping it because I don't need this, but it will take 10-15 minutes, but it will it will be downloaded. So once you run till this part, there will be two files generated, one from this line and one from this line. One will be a .hp file, one will be a .json file. So you just keep both the files downloaded. Okay, so this would be enough for me for to start our class tomorrow. So let me know, do we have any doubts any further? It's my pleasure, Vishnu. Do we have any doubts, guys? No doubts? Okay. If you guys come across any doubt which you want to if you guys come across any doubt or anything, so definitely come tomorrow. We generally have our doubt session from 4:45 till 5:15 or something, so you will be notified about the timing in the mail, I think so. So you can come over there and we will be solving all the doubts over there. Okay.